Hello.
Suhas sir, I
Yes,
have
sir.
given a yes sir,
My voice is clear, right?
yes sir, yes, your voice is clear. Sir, I have given a right to share your screen. You can check.
Yeah, yeah.
Yes. Okay.
Should I share my screen or right
Yes sir,
now?
please you can check now whether it is you are
Okay.
able to share your screen or not.
Is it visible?
Yes sir, yes sir. Your
Okay.
screen is
Thank you.
clearly visible. Your audio is also very loud and clear, sir.
Okay.
Yes. We'll wait for 4 to 5 minutes, sir.
Yeah,
because the
sure.
participants are going to join, and we'll start the session at 2 o'clock. Yeah,
Okay.
yeah, yes. Okay, sir, I think the sufficient number of participants are now joined. Suhas sir, are you there?
Yes, sir. Yeah.
Yeah, okay. So, shall we start?
Yeah, sure.
Okay.
Uh,
Okay, sir. Just a minute, sir. So, I welcome all the participants for the this final day of the faculty development program on leveraging cutting edge technologies. So we have basically the theme of this FDP is the sustainable agriculture practices, and we are using from last 5 days. This is our last day. We have a various technology, the use of various technologies. We have seen how it can be implemented for the agriculture practices. So today we have the session is on actually the rural community development through techno-social collaborations. So for this, basically we know we should have a just like people are nowadays developing different technologies for the social aspect like agriculture or the farmers or even for villages. So the how the technology can be implemented, how we should reach to the villages. So to give the glimpses of this type of collaborations, I requested the Suhasa to give some words of wisdom on this one. So today we have speaker is Mr. Suhas Labre. He is the manager at Vigyan Ashram Pabad in Pune. He holds a master's degree in electronics engineering and has over more than 12 plus years of work experience managing techno-social interventions to develop appropriate technologies and programs that bridge the gap between technology and the society. Currently, he works as a core staff and Fab Lab manager at Vigyan Ashram in Pawad, Pune. In addition, he is a global evaluator, remote instructor, and regional reviewer for a Fab Academy course by Fab Foundation USA. He possesses skills in project management, core electronics, IoT application, CNC manufacturing, and operations. So, with his vast experience in techno-social interventions and developing different projects for the social aspect, I hope his session is going to help many participants, those who are developing their applications for the agriculture. So, I request sir to start with his session. Sir, please.
yeah. Thank you, sir. Thanks for giving me opportunity for presenting this in this FDP. Sir, given my introduction already, so I'm not introducing myself again. So today I'm going to talk about the topic rural community development through techno-social collaborations. And uh, I'm from organization Vigyan Ashram. So I'll introduce a little bit about, first of all, Vigyan Ashram. What is Vigyan Ashram? How it is started, and then will we see different technologies which is developed by Vigyan Ashram, and those are benefiting to the rural community. And we are having different collaborations as well to the technical institutes and then social organizations. So I'll take you to the tour of different technologies and how we made different collaborations with these institute organizations. So I will first of all give a little bit idea about the Vigyan Ashram and the programs in Vigyan Ashram. Just the screen is not going. Okay. So this one is the Vigyan Ashram's campus. So our organization is located around 170 kilometers from Mumbai and around 70 kilometers from Pune city. And it is a remote and a rural type of setup. It's a small village called Pabal. Pabal is famous for Bajirao and Bajirao Mastani. That Mastani cover is there. And then there is Jain temple is also there. And then it was started in 1983 by late Dr. S.S. Kalbag, who is scientist. And then he seen ki there are so many chances, there's so many opportunities in rural areas at that time because Pabal is drought village. There is no water it requires some tankers in the summer days. And then at that time, again, electric connection and the transportation was the issue. So that's why he selected that Pabal village, because there are so many problems are there, and then there are so many opportunities. So Pabal is dot village, very simple village, and then there are no facilities at that time in the Pabal village. Right now, they got very good transportation and then the some water resources as well. But at that time, it was very difficult. So Dr. Kalbag started Vigyan Ashram. So Vigyan Ashram is a non-profit organization, and then we provides means the main objective of the Vigyan Ashram is like rural development, rural technology development, and then education sector. So we have some of the programs, skill training programs, and then we are also in research. We are also developing some rural technologies to support the nearby farmers and all. Okay. So these are the programs we are running right now. So some of the programs for schools, some of programs for skill enhancement. So first program is our core program is like DBRT, Diploma in Basic Rural Technology. So in DBRT, we gives admission to the dropout student, which is thrown by our education system. We gives them admission. Okay, so 10 dropout, 12 dropout. We provide them admission, and then we gives them skill-based training. So we have a nature where we're considering nature as a syllabus, and we have a 4 sections: engineering. Then we provide training in electrical, improvised training in food processing, and then agriculture and animal husbandry. So within the 1 year, so DBRT program is for 1 year and it's a residential course. So within 1 year, that student passes through different sections, and then after completion of the 1 year, he got clear idea about what he have to do after that. So most of the student, around 60% of the student of this program, goes for the entrepreneurship, and they starts their metal fabrication workshop, electrical shops, kind of, or some bakery kind of things. So this one is the one DBRT program. Then another program Vigyan Ashram runs is Introduction to Basic Technology. So whatever syllabus we are teaching in DBRT in 1 year, we teaches same syllabus in schools in formal education for 3 years in 8th, 9th, and 10th standard. So in that school, they need to have a establish that facility for 4 sections, and then we teaches them all the syllabus. We conducts teachers training program for the schools, and then we try to give whatever we are teaching on campus to the school students as well. Then third program and most important program is Design Innovation Center. So in that program, we develop so many rural technologies. Okay, so Design Innovation Center is again, this is a government initiative, and most of the IITs have these centers, Design Innovation Center. But out of IIT, only Pune University is having this center. Okay, and then one of the spoke center is Vigyan Ashram. So under this design innovation center, we are also having 4 programs again. So one is agriculture and microbiology. Second one is the sensor technology, then product design, and then water and waste management. So we teaches these 4 courses under DIC, and it's again a 6-month program. And then student have to come here, means undergraduate student for internship, graduate student for the fellowship. We gives them admissions, and then they have to stay on campus for 6 months, and then they have to work on some different technologies or some research project. Okay. Then we have another program called Fab Academy. So we have a digital fabrication lab, and then which is again affiliated with the MIT Boston. And then we runs a 6-month course in the digital fabrication called Fab Academy. So again, that students have to stay on campus, and they have to work with all the digital fabrication practices on the campus. So for to run all these programs, we have different applications and then collaborations. So NIOS, the DBRT student gets certificate from National Institute of Open Schooling. Then DIC student gets certificate from Savitribai Phule Pune University. Then this IBT and DBRT students, again, if they want some specific kind of skill training certificate, like Electronic Sectors Council certificate, or any other type, means sectors council certificate in solar technology, So this type of certificates we also provides because they have to appear for the exam, and then they have to give that exam, and then after that they get this type of certificate. So we have collaborations with all these institutes, government institutes. So Vigyan Ashram mainly focuses uh, the different initiatives like by World Sustainable Goals. So we are mainly focusing on how we can make our villages self-sustainable in terms of energy, in terms of education, in terms of agriculture, in terms of waste management. So where we're looking these four areas and our villages. So if the villages are become self-sufficient in terms of all these things, then the migration and all the crowd in city, all these things, the population in the city, all these things will stop. So we are right now working on different technologies to make the self-sufficient these villages. So these are the key pillars of Vigyan Ashram. So methodology we are following is these are the key pillars. So first pillar is like learning while doing. So most of the our courses is focusing on learning while doing concepts. So most of our syllabus is a practical syllabus. Means 80% practical and 20% theory we are following. Then every student have to provide some community service. Even in that IBT program in school, that IBT students from the 8th, 9th, and 10th standard, they have to give some community service in their villages. Okay, so our community is our customer, and then student have to develop some of the things or some of the technology which is beneficial for the community. So every product, every project, we have customer, and then student have to talk with that customer, and then get feedbacks from and make some continuous improvements in that product project, and then they have to again go to the community. So provide the services to the community is the again second pillar. Then third one is the data driven approach. So research is again the fundamental thing. So whatever projects, whatever products we are developing, we does all the things. We survey whatever design thinking stages are there. So these stages we goes through these stages, and then at every stage we collect the data. So we are having data of means rainfall from last 30 years in Pabal, is that record. And then we have data of temperature and humidity of Pabal village from last 30 years. So everything, whatever we are going to test, whatever going to develop some project or anything, we collect the data, we makes it document, makes its document, and then we goes through the analysis and all the things, and then we makes the result. Okay, so this one is the third thing. Then the projects we took, it may requires involvement from the teacher side or the expertise side. So our philosophy tells like our instructor must be our entrepreneur. So he needs to have entrepreneurship skills. He have to start some startups or some business by his own, and after that he can teach all these concepts, all these things, his experience to the students. So that one is the fourth pillar. Then we follows the design thinking methodology in all the projects, and then last one is the peer-to-peer learning, is interdisciplinary projects is there. So we are not like consider I am an electronic engineer, but I am not focusing only electronic project. I focuses I have to work on some agriculture related thing. I have to check the leaf size, root, and then the permanent wilting point of the soil, all the things, means soil microbiology, then agriculture, then little bit about the electronics, all the things I have to work. So this is not any stream specific or any field specific. Our all the projects are having a different fields, and then that students have to go through all the things. So this one is about the Vigyan Ashram, and then now we'll move forward to our topic. So if we see rural areas, so why Vigyan Ashram is started in Pabal, or why Dr. Kalbag thinks about to start this center at Pabal village, because it's a there is no resources, and there are at that time it's very difficult to come to the Pabal as well, because no transportation facilities are there. So still he started the Vigyan Ashram Center at Pabal, because there are so many opportunity in terms of energy, transport, production, agriculture, environment. There are so many issues, and that's why he thought about to start the Vigyan Ashram at Pabal. So if you see our rural areas, if you see the different villages, then there are so many opportunities to work on. There are different problems are there. So if we see these problems as an opportunity, then you can go through that problem and develop some innovative solutions out of that. So I'll take you to the tour of different projects we developed with same approach. And then for to develop these projects, we had different collaborations with different institutes and different technical organizations. Then we have a collaboration with some social organization as well to deploy the projects. We have a collaboration with the schools, different government agencies. So I'll by project specific, I'll give you the tour of the technologies developed by the Vigyan Ashram, and then how we are collaborating with different uh, institutes. So first one is the DIC, Design Innovation Center. So what I told before, Design Innovation Center is the one of the spoke center of Pune University. And through this center, we are running one course, designing a solution. And through that course, we get some interns, some fellows. So one of the fellow from this DIC center, uh, whose name is Shubham Shemde, he's again, he joined that center in 2016. And at that time, he was pursuing his BA degree. He's in last year of the bachelor in mechanical engineering. And then he came to Vigyan Ashram. He was from Pabal. And then he was mechanical engineer, so that's why he decided to work in some mechanical kind of thermodynamics kind of project. So we given them project of solar dryer, and then after that he developed some dome shape type of dryer, because one of the self-help group from Bhima Shankar side, they came to us and then they requested us to develop some solution to try their products. So that's why we given that problem statement to the Shubham, and then he came up with some solution. So whatever you are seeing in picture, so these are the geodesic dome structures. Again, that was one of the project in 1990. Vigyan Ashram developed this type of geodesic structures, and then right now we have some of the structures on campus. So that's why he thought he will use these structures to dry the vegetables. So the concept of dome dryer he evolved. And after that, he tried that things on different pages, and he got super results. Uh, so to test the results, he again developed some low temp that drying apparatus to check the drying rate of different veggies. And then this one is the apparatus he developed to check the moisture content into the veggies and how much time it will take to get it out. So this one is the lower scale version of that bigger dome dryer, and he developed this. He made the engineering CAD models of these dome dryer, and this one is the fabrication process. He ordered aluminum sheets and then he made the dome shape. And this one is the one went at the top to take out all the air. So after finishing of this product with the successful results, he deployed that product to that Bhima Shankar NGO, a self-help group. And then he again taken some feedbacks. He also deployed that product to one of the industry which is near to us, and then he got very good results. So this one is the analysis. After that, after Shubham left to the that course, these are the students: Girija, Srikant, Ame, Pramod. All these are from rural background students, and they came to Vigyan Ashram and they again developed this tire. They taken forward this tire concept, and then they made some uh, modifications into that. And then after that, we given that again to the one industry. So this one is the Anandagana industry, which is near to the Pabal campus. And then they are selling like dried products, ready to cook products. So they purchase our dryer. So if you see in that news, there is small version of this dryer and then bigger version of this dryer. So they dries all the veggies. If you see, spinach powder is there, then beetroot powder is there, carrot root powder is there. So this Gitaram Kadam, who is a founder of that Anandagana Industries, he's selling this dried product, and then to dry these effectively, uh, they purchase this dryer, and then now he's using that. So this one is the dryer. After that, with seeing these things on our website, some social media space, uh, one of the NGO from Kudal, from Konkan, uh, from Sindhudurg district, they come to us, and then they told us ki one of uh, our fisherwoman has a problem of drying the fishes, because every day 1 to 2 kg of fish remains unsold, and that's why she throws away, because she normally does the sun drying, and then uh, because of the dust and all the things, it is not that much effective. So they requested us to develop some product for us. So Shubham already had some study, all the things, how drying process is there. So based on that study, we developed another dryer called flat bed dryer, and which quotes, we given quotation around 70,000 rupees, 1,700, 70,000 rupees to that NGO. And then this one is another student, Purneshwar. He developed that flat bed dryer, and then we provided them to that NGO from the Kudal. And then after that, again, another person came to us from Solapur district, and then he requested again to try their veggies. He requested to again one of flatbed try. Then another student, Nandini, she worked on that again, manufacturing of the tire, and then we provided. We completed that order as well to try the Amla candy, Puran mix, all these type of rice. So these are the technologies. Means this one is the technology, tying technology we provided to the NGO, and then indirectly it benefits to the rural community. Then this one is the commercial dryer for the grape farmer. Again, with seeing where Vigyan Ashram is working in drying. Then one of the farmer group from Nashik, they came to us, and then they requested us again to develop some dryers to dry grapes to make the resins. So this one is the dryer we develop in collaboration with the Bhabha Atomic Research Center. So one of our student, Amey Kulkarni, was did his PhD from Baba Atomic Research Center, and at that time he took subject for as a drying technology, and then under that he developed this type of dryer. It's a tunnel dryer, and then if you see, these are the grapes, and then he got around 40% time reduction to with this type of structure, and then again we deployed that to the grape farmer, one of the grape farmer in Nashik, and then right now they are working, they are using that. So right now again, we also did again empathy in the MP, Madhya Pradesh, Nimad region. And if you see in Nandurbar region also, so the red chili production is very much there. So to dry these chilies, we are also currently right now, we are developing another type of dryer. It's again dome dryer. And then we want to develop this type of dryer, because in empathy we found so many problems from the farmer side. This one is these are the this Miro chart we developed. Whatever empathy that our team did. So this one is the Miro chart they developed. So this one is means they are having a problem with the fungus. Means some dark spots are coming on the chilies. Then to picking up the chili, there is another problem they told. Then to dry, it is very challenging for them, because there are so many big uh, collections are there, and then to put them for the sun time every day is very difficult for them. So they requested us some solutions, and that's why we are developing this type of dryer right now for the chili to dry the chilies, and it's having a 200 kg capacity. And right now we deployed that in again that Nimar region of Madhya Pradesh to test it out. So this one is the technology in dryer we developed, and these are the some of the collaborations we made with Baba Atomic Research Center and then Pune University uh, to make that happen. Right now, we got funding from Department of Science and Technology to work on this problem for chili drying, and then we developed some around 2 prototypes to test it out. Then another problem, which is again I'm taking you in 1999. So Vigyan Ashram is looks like this. Means this one is the hill, it's a barren hill at that time, and then this one is in downward side. There is a photo of Vigyan Ashram campus at that time. This is a if you see there is a dry land, and at that time in 1999 we started internet in Pabal. So at that time it was very difficult in to send one email from Pabal. So at that time, what we used to do, we takes that email, we writes that email, and then we stores that in floppy disk, and then we takes that floppy disk to the Pune, and then we sends that email from Pune. So again, at that time, we started with collaboration with IIT Chennai. We started this Chirag Internet Kendra in Pabal, and we provided services. Means this one is the tower at Viganasham campus built it at that time, and then we provided around the internet service to the 60 village, and the cell phone service around 72 villages in the tribal area of that Bhimashankar belt. So at that time we developed, we made a collaborations with the IIT Chennai, and then they given us one center, and then uh, in collaboration we developed this technology, and then it again benefited to the community. Same time at we made the collaboration with the IIT Poway, and we developed this aqua site, which is again right now there are so many solutions like prediction solutions for the farmers. Then some notification system is there, because right now because of the AI and the IoT, we are developing so many devices very easily. But at that time, with the help of IIT Powai and the Vigyan Ashram, we developed first time this Aqua website, and then through this website we sends the notifications about the about the weather prediction to the farmers, and then farmers. This one is the platform farmers can use to put their questions in Marathi language, in different languages, and then they can ask their questions, and immediately they gets answer from the IIT experts on that question. So this one is the technology again we developed for the farmers at that time. So this one is the again rate chart, means rate different crop rates during the day, and then we they can able to visualize at that time the rate of each product. So this one is the news coverage of this site. Uh, of the Aqua site, where SMS is means through SMS they gives the weather prediction notifications. So this one is the team. The 3 members are from Vigyan Ashram and 2 members are from IIT lab. So at that time they developed this type of technology. Then with again IIT lab, IIT Powai, we are also trying to some experiment in education. So so what I told before, we want to make Pabal as a self-sustainable village, and we for that we started first from our campus. So we are making Vigyan Ashram campus self-sustainable in terms of energy, agriculture, education, and the waste management. So we did so many experiments on this, and then we want to try these experiments. So we tried these experiments again with one of the school. So from Vigyan Ashram, there is around 20 kilometers, there is one village, Mukhai. So they are having a ashram school, and around 500 students are staying on campus in that school. So with help of that IIT lab, they started one program called Living Lab. So in collaboration with the German organizations. So in IIT, there is Sitara department. So with help of that Sitara department, we installed some of the projects in this ashram school. And then these are the solar water heaters we installed with help of them. We took help from, again, dissolve system. Then some local community, they also contributed some of the amount, and they donated again this solar water system. Then these are the projects are from IIT lab, IIT that living lab. So this one is the gasifier, around 30 kg, uh, uh, around 30 kg kitchen waste they are producing every day. So it goes to the biogas. So this biogas technology is developed in IIT, and they implement that technology to the some of the schools. So that's why we requested IIT lab to implement that in that school, and then we'll check out the results and all these things. So that's why they install that setup in that Mukai school. So gasifier, then biogas, all these things we install in collaboration with the IIT, and then right now they are fully sufficient. Means it is uh, self, means they are now, right now sustaining the energy cost uh, that ashram school. So this one is the collaboration with the IIT lab. Then again with again same that living lab collaboration, we got electrical vehicles, electric rickshaw. So if you see on rural side, we are not seeing that much electrical rickshaw kind of things, right? This type of vehicles. We are seeing a lot of electric cars, but right now electrical rickshaws are not there because it's very difficult to uh, generate the torque and generate that kind of movement uh, in the rural roads. So we tested these two rickshaws given by the IIT lab, and then we submitted report to them because it's having some limitations. So we also again we are seeing the transport facilities. Means we are working on that facilities also. How we can provide, how we can enhance the public transport system, uh, and how we can make these as energy efficient also. So with the collaboration with IIT, we are testing these projects. Then we see in the Design Innovation Center. Then another facility we have the Fab Lab. It's a digital fabrication lab. So for this facility, again, we have a collaboration with the MIT Boston. And then with help of this Fab Lab, this digital fabrication setup, we develop so many technologies. So the concept of Fab Lab is like you will have all the prototyping tools like 3D printer, laser cutter, then electronic setup, then vinyl cutter machine, CNC milling machine. So this is a setup with all the digital tools, and then you have to go with your design, and then you can fabricate most of the things which is required for your project. So you can go up to proof of concept, you can go up to prototyping level. So because of this Fab Lab, uh, we are able to develop most of the rural technologies, because if you need some electronic board or some sensor, specialized sensor kind of thing, or some structure, then you can easily fabricate in the remote village as well. So we have say this setup. So this one is the founder of Fab Lab, Neil Greshamfield, who is a professor at Center of Bits and Atoms at MIT Boston. And then he's having this concept. He came to Vigyan Ashram at 2002, and then at that time he's seen the Vigyan Ashram's practices in different things, and then he discussed with Dr. Kalbag, who is founder of Vigyan Ashram, and then he told to Dr. Kalbag, send us all the problem statements from Pabal or nearby villages, and then at MIT, and then our PhD student will work on that, and then we'll send the solution back. So we tried that thing for next 6 months. We collected all the problem statement near to the Pabal village, and then we sent to the MIT. But to understand this problem statement is very difficult for these MIT students, because our problem statement is very real, and then it needs some practical experience, right? So at that time it is not work. So that's why again Kalbak returned to the Dr. Neil and told him ki, instead of giving us a ready-made solution, give us some advanced tools, and then we'll develop our solution at our campus. We can check our problems, and then we can develop our solution. Give us advanced tools, give us training, and then we'll make our own solutions. So again, Neil liked that concept, and then after that, he given that full-fledged Fab Lab setup. So that includes that PCB milling machine, then laser cutter, 3D printer, all the things, means all electronic inventory, power tools. And then after that, they provided the training, and that Fab Lab concept evolved. So in 2002, world's first Fab Lab started in Vigyanashram, and after that, he repeated same concept to the different with different concept, countries, and then uh, right now around 2700 Fab Labs are there into the world, and then they are right now working in collaboration. With the Fab Lab, we are again running one course called Fab Academy. So through that course, we teaches all the digital fabrication concepts and the processes to the students. And then after completion of that course, most of the student starts their enterprises. Most of the students works as a Fab Lab manager, innovation spaces manager in different cities, and most of student goes to the study for outside. So this one is the Fab Academy course. So these are the things we developed under Fab Lab, and then I'm going through again another technologies which is developed under this Fab Lab setup. So these are the few projects these are the prototypes we develop through the Fab Lab. So he's having a sanitary pad incinerator. So it's a LPG gas incinerator. Then smart warehouse for the onions. Then EPC solar drum tire to make that again to check the data and all the things. We develop some system uh, uh, for the data logging. We develop some UV solar water filters, then routers, then to measure the weight of goods and to plot the graph to maintain the history of that good. We developed this smart weight measuring units. Then we work on composters also. So these are some of the technologies we developed under this with the help of this Fab Lab setup and the collaboration with the MIT. So I'm going through in little bit in detail some of the technologies. So this one is the egg incubator. And so one of our student, that student is 10 dropout who came for the DVRT course in Vigyanash. And then he took one of the project is like hatching of the eggs in DVRT course. And after that, he got success. And then he developed that project after completion of his DBRT course with the help of Fab Lab. He developed that project, and right now he's having the his own business in manufacturing of egg incubators. Right now he's manufacturing the egg incubators with the 5,000 eggs capacity, and he's selling these units at different places. So this one is the again one of the project developed by the Viganashram Fab Lab. And then with seeing these units, some of the NGOs, some of the self-help groups, they approached us and then they requested to use this technology. And then we provided them this type of egg incubators. So this one is the one of the lady, Aruna Kalaskar. She is from Tandali village, which is near to the again Vigyan Ashram campus. So she took this unit and then she started their own business. The business name is Sanyog Prakalpa, and right now she's this. At that time, she earned like every day. Means earning is like a 9,100 rupees, and for the 90 days, and the approximate she's earning around 60 rupees per day. So this one is the facility. Means this one is the technology how this is benefiting to the that rural woman. Then another technology again, another NGO which is again near to us from Rajguru Nagar village that approached us, and then they requested, because Rajguru Nagar, if you see Rajguru Nagar Tehsil, then is a having a small villages which is tribal villages, and they produces rice. So they requested us to provide the personalized rice dehusking machines to take out the husk from the rice, because most of the farmers gives that raw rice with the husk to the polishing mills, and then they get very little benefit. So that's why they requested us to develop some machine uh, for individual farmer, so that he can produce he can polish that rice at his home. So this rice de-husking machine we developed. So if we see with again same person, that same student developed this rice de-husking machine at that time, and then we provided that machine to the one of the NGO. We requested that. So Chaitanya Trust, the name of the NGO, and then with help of this NGO, we reached out to that tribal community with this machine. So that again, news coverage came into the different newspapers, and that person again got so many orders from Konkan region as well. Those even from south also. So he deployed these type of machines, and right now we have a technology collaborations with this climber system to produce this rice de-husking machine technology. If we got some order from any of tribal region or any of rice producing farmer, then we gives the this system is this climber system is producing this rice de-husking machine right now. So we did the technology transfer, and right now they are taking care of this production. So this one is the another technology which is again benefiting to the rural community. And then right now these farmers, these self-help groups, they are selling the brown rice, because this machine is having the adjustment to how much you want to put a pressure on the rice surface. So you can adjust that pressure, and then you can take out only husk, not polish to the rice. That's why. Uh, this technology right now providing a lot of benefits to the small farmers, and they are producing all these things at their home, and then now they are started selling in package to the malls and all, and they are getting more benefits out of that. Then another technology again, sprouts. So in our campus, around 100 students are staying on campus. So our daily requirement for the all the things are huge. So that's why we decided to develop the sprouts, some sprouting machine. Because if you see the traditional method, there are so many things, so many challenges are there. Uh, because in traditional method, what we did, we tied that seeds in a cloth, and then we put them in some different places. But because of this traditional method, there's some seeds are not that much grows with a sprout that much not grows fastly, because of not getting that favorable conditions like temperature, humidity. And most of the time that anaerobic growth happens, and then it starts smells and all the things. Okay, so these are the challenges in the sprouting. So again, we started working on that. We did some research. So this one is the one girl from DIC course. She tried different methods. So this one is the data we collected. So amount of mudki we are putting, and then amount of water we added, and then we seen the results. These are the graphs. Then this is the sprouting rate she calculated. She calculated the weight of each thing, and then uh, we developed this technology package, and we right now we are transferring this technology package to the rural women or other women, those who are having the self-help groups. So we have a IBT network, is the IBT school network as well. So we develop this technology, and with this network, we are transferring this technology to the again villages, so that they can grow these sprouts, and they can sell it easily. So the sprouting time we reduced it. Then in Fab Lab, another student came, and then he worked on again another problem of that sprouting. If we see in sprouting, if we put two seeds together, and if we tie that seeds together, then the water between these seeds, it gets traps, and then anaerobic growth happens, and then some fungus or some smells comes out. So this student Rahul Kanojia, he worked on that problem, and then he developed some prototype in FabLab with FabLab tools. So he made one unit. So all these are fabricated with the laser cutter, 3D printer, and all. So this unit is having a one cylinder. which is rotating. And then because of this rotations, continuous rotation, the air gets involved in that seeds, and then some aerobic growth happens. So no smell, no fungal growth is there. And then because of the rotation and this shaking, the water comes out. That trap of water also comes out. So this one is the things he used the Fab Lab setup, and then he developed the entire prototype. And after that, right now we developed another version of that sprouter. And then right now we are using that sprouter in our kitchen. We also got some orders from the Pune city, which is those who are having a big kitchen facilities. And we developed that facility, that capacity sprouters, and we also provided to them. So these are the technologies again we develop with the help of Fab Lab, and then we deploy it to the community. And then again, the approach is like we want to solve the problem of rural community, and then right now these technologies are benefiting to them. So the method is like we are studying science as well. We are collecting the problems. Then we did some experimentation, and then through that experimentation we collect the data, and then we applies that to the innovation. So these are the some of the things like Murgar's production, then fodder production. We are trying again as another source to the food, source of food for the cows, for the animal husbandry. So this one is the fodder production we are tried in Vigan Ashram campus, and after that through our school network, this one is the other Prashala Nagaj. So we tested all the things. Means this one is the fodder production using the hydroponic technique. So we maintain the temperature and humidity of these setups, and then after that you will get the good fodder production. So this technology again we transfer to the one of our school network, and then this other Prashala Nagaj, they are implementing at their campus, and then they are again transferring this technology to the village level as well. So with this school network, we are transferring whatever technology we are developing on campus. We are transferring all these technologies to the village level. So this one is the further whatever we did. This one is the experimentation. These are the different stages at different days. And then this one is the height we calculated, weight we calculated, and then if you see on the left hand side, the days are there, and then the vegetative growth we counted, and then height and weight, these are the parameters we counted. And after that, at what time we have to take it out, we also uh, uh, given that technology package to the schools. So these are the things. Means if you see the photo production is there, then this one is on right hand side. If you see some CAD model, so this one is the unit we develop for the hydroponic system. So this one you can grow spinach or any kothambir kind of thing into this. And then this one is the vertical model of hydroponics. And then through these pipes, you can run the water, and then it grows on water. This is one of the method to one of the method of soilless garden. So again, this NGO Nisargayan. So we transferred all the technologies to the Nisargayan, which is again he's one of the employee of Vigan Ashram. He started his startup Nisargayan, and then right now he's consulting. He's making all this product, and he's deploying to the different customers. So this one is the one of the, so along with the technologies we are developing, means we are using technology also. So this one is the AR/VR demonstration of this hydroponic model. So if you see, this one is the AR model, augmented reality. So to demonstrate at different locations or to educate the people, rural people, who uses these technologies. Again, next thing is energy. So if you see, energy is one of the major component for our country. And if we become self-sufficient in terms of energy, then our GDP will grow, and then will become the one of the biggest country in the energy self-sufficiency. So right now, if you see overall production, means that solar energy and all, we are at fourth place in terms of solar energy. So Viganasham is also trying different experiment to make the villages self-sufficient in terms of energy. So uh, right now we are focusing on our campus. After that, we'll go to the Pabal village and then we'll replicate same model to the different villages as well. So these are the some of the examples. Like we reduced our consumption. Like we on our campus, we are using all the DC appliances. Means our fans are DC or all the motors are DC. Our tire lights are DC, means that LED lights. Then our sieving machine is also working on solar energy. Our most of the grinder is workshop tools, grinder, then drilling machines. All these are works on solar energy. So we are making our campus right now self-sufficient in terms of the energy. We have a 5 kilowatt solar net metering system right now. And then we are also experiment some of the solar thermal things like I already told that solar dryer. So water heating system, solar cooking applications, dryers. We are also trying different experiments on the solar thermal energy as well. So these are the things we are trying: solar heaters, light bulbs, then DC fans are there, and we reduced around 40% energy consumption of our campus because of all these solar implementation. We are also generating our energy. So these are the some of the experiment with help of a Selco Foundation from Bangalore. Uh, we tested some of the technology at our campus, and after testing, we implemented these technologies to the different villages. So these are the technologies. So solar power polyhouse, fan pad system, then grid system, then sieving machine, solar sieving machine, then milking machine, then solar refrigerator. These milking machine and refrigerator very much beneficial for the small entrepreneurs. So we provided them to the different villages near to the power in subsidized cost. And then we developed some solar lightning solutions like in flex, on flex, there are some LED lights are there, and then we can easily put that lights on solar energy. So solar fridge, solar refrigerators, solar uh, computer computer systems, computer and printing system. If you see some tribal areas, there are these areas will not have the electricity supplies. So at that places, we can easily use these solar operated computer systems and printing systems. So most of the stations we given into tribal areas, and these peoples right now they are using that, and then uh, they are running on solar energy. The entire setup is running on solar energy. So these are the beneficiaries of that solar products. So solar milking machine we sold around 9 farmers. We given solar sieving machine around 4 women's. Then solar fridge 4 women. Solar blacksmithy. So solar operated bhata is there. So we given to the uh, two of our Miss in Pabal village. We given to the 2 persons, and then as solar computer centers we provided around 7. So with the help of Selco Foundation from Bangalore, we uh, tested all these equipments, their invention, our inventions, and then we deployed it to the different villages. And uh, right now, most of the peoples are using that. This one is the micro solar dome installations we made with help of again NB Institute of Rural Technology from West Bengal. So we're having collaborations with different DST supported organization. DST means Department of Science and Technology. So Department of Science and Technology supports many organizations, NGOs in entire country. And then we have a collaborations with all these organizations. So this one is the NB Institute of Rural Technology from West Bengal. They made one product called Micro Solar Dome to use, this one is the product which gives lightning solution at the night time as well as daytime. So during the daytime, it uses the solar radiation and it refracts that radiation and it passes to the house. And during night time, this dome is having a battery and then LEDs. And then at that time, you can use that LEDs and the you can charge that battery. with the solar radiation. So we made this type of this technology is developed by NB Institute of Rural Technology, and we taken that technology and we implemented, we installed this type of solar domes in our Bhimashankar area. So these are the beneficiaries, and if you see during the daytime also they are having some darkness inside their house. So we installed these domes in the tribal areas of Bhimashankar. And then this one is the Velle area, again, tribal part of the near to the Pune. So we install this type of domes, and if you see, there are solar panels, and then there is dome. So because of that dome, it transfers the light inside during the daytime. And this one is the Dantewada region of the Chhattisgarh. Again, this one is again tribal part and most aspirational part. So in that area also we installed this micro solar dome. So we made the collaboration with NB Institute of Rural Technology, and then their technology we deploy to the uh, again to the required community. Then we also working on in waste management. So this one is the BSF. BSF means black soldier flies. So black soldier flies is one of the fly. And if you see, this one is the life cycle of that fly. So this is having a larva stage. This one is the egg stage, and then another this one is the second pupa larva stage, and then pupa, and then after that it becomes fly. So right now we are having a collaboration with the Rajguru Nagar Municipal Corporation, and then right now with help of these black soldier flies, uh, we are processing around 2 ton waste garbage, wet garbage that came from again kitchen, and we are converting them into the manure compost. So this larva is very we collect the different we have a breeding chamber of this on our campus, and then we take eggs of these flies, and then we put these eggs into the kitchen waste. So on that kitchen waste is acting as a feed for these larvas. So these larvas eats that kitchen waste and decomposes that, and after that it grows on that kitchen waste, and then uh, we takes them these larvas out, uh, and this larvas is acting as a very good source of food to the poultry industry. So it is very rich with the protein, uh, and because of that we are where miss if we feed these larvas to the uh, uh, poultry, it goes again through the poultry, it comes again to the human. So whatever deficiency, protein deficiency we are facing right now, so we can meet that. So at the same time, we are getting the byproduct as a compost, and at the same time, we are getting some commercial value from through the larva. Uh, that product we can sell again to the poultry farmer. So right now we are developing this entire chain, and we tested all these things, the entire chain to the on the Vigyan Ashram campus, and after right now we are testing this with the municipal corporation of Rajguru Nagar, and now we are processing around 2 ton of wet garbage there, and this one is the one again good solution. Means without harming anything, it will between convert whatever wet waste is there into the compost. So this one is one of the technology we are trying right now. So these are the stats of this. It requires again for that larva to grow, it needs to have 60% humidity and the temperature. So that breeding chamber needs to have control system. So this one is the another that one is the for the waste management. Then water again, from 1983 we are working on different projects related to the water, because drinking water is the main problem in Pabal village, and the belt around 12 to 13 villages are there in this belt, so is having the same problem. So during that time around 1983 to 93 we work on the problem is we uh, provided training in hand pumps and maintenance of the hand pumps to the rural youth. After that, we developed earth resistivity meter during the 87 to 97. We developed earth resistivity meter to find out the groundwater level. So around during that time, the borewell concept came, and then around 3,000 borewells we tested successfully through this earth resistivity meter. And then again, some natural environment concerns are there. So uh, we tested this again. We allowed this to up to 150 feet to check the groundwater level. So due to the environmental concern, we not increase that capacity. And right now, if we see, there are different technologies to test the earth resistivity and find the groundwater level. But at that time again, during 1987 and 97, we developed this technology to check the groundwater level. So these are the some of the projects we worked after that because Pabar is a dot village, so every drop is important for us. So we are having means if you see our campus, then we are having grey water recycling systems everywhere. So on our student hostel, ladies hostel, uh, all the hostels are having a grey water recycling units, and then we are using this grey water after treatment. We are using this to the our agriculture plots. So these are the some of the experiments we made with help of Fab Lab setup and the Design Innovation Center. This one is the standardized system right now we are having for the gray water treatment. So this one is the CAD model of that. We experimented so many things, and after that we came up with this portable solution. So this one is the portable model we developed. So these are the tanks, and then it collects. This tank will collect all the gray water. It will pass through different stages. This tank will collect this blue tank will collect the gray water. It will pass through these different stages. This one is the siphon method we used, and then after that, after treating, it comes to the again collection tank, and you can we are doing here air bubbling to put oxygen into that to avoid the smell and all the things. And then after that, we are using this for the agriculture plots. So these are the some of the installations we made installation in that Mukai residential school for their hostel. Then uh, if you see some small ponds, they need some air bubbling systems and all. So at there also we install this system. So again, to use every drop of water, we are developed this type of systems in water. Uh, for the drinking water, we can Ashram also work on different types of filters. So I'll take you to through that as well. So this one is the uh, from 90s where we are working on drinking water filters. So these are the some of the experiments what we did. So initially we tried iodination process, chlorination process. So you know the medicolor bottle right now, but at that time we put chlorine into the water to kill the bacteria and viruses. After that, we use ceramic candle type of filters, which is available before. Then we develop our own filter kit. So these are the candles, activated carbon candle, sediment filter candles are right now available in very easily. But at that time, we tried this type of candles. We generated that activated carbon on campus, and after that, we tested this type of candles with water. And right now, if you see in Vigyan Ashram, these type of filters are there installed. We made these filters. These are not RO filters. This one is having only carbon candle, and then some sediment type of candles, and then ultraviolet light to kill the bacteria and viruses. So these are the different tests we did. We tested bark technology as well. So this in middle, they developed one technology, one chemical membrane uh, to filter out all the impurities from the water. So we tested that technology, but again, they developed this for the urban areas, not for the rural areas. So that's why it was not that much effective in the rural areas. So we return, we tested, and we return the feedback from our side to the bark. Then we develop right now. We have the product, this UV portable water filter. So if you see some sugarcane industry, there are so many nomadic tribes are there, and they drinks water whatever available to the nearby. So from river, from well, they drinks that water, and then there are so many waterborne diseases are there, typhoid, pneumonia are there. So keeping in mind this community, we develop some solution for them. So the project name is UV portable water filter. So the water with TDS value less than 400 ppm is drinkable. If you see World Health Organization's stats, so TDS which is having 400 ppm less value, then it considered as a drinkable water. So right now, if we see our wells and the rivers, they are having TDS less than 400 ppm, and then no need to use the RO type of filtration technology, which is again wasting so much water. So that's why we come up with this solution. Those areas who are having the TDS 400 less than 400 ppm, they can use this technology. So this one is the some of the test we tested. So this one is the UV light. It's a submersible UV tube, and then you have to fix that UV tube at the top of your maybe any pot, and then you have to give around 15 minutes exposure this to the 20-liter water, and after that it kills all the bacteria and viruses into that in in water. So we tested this technology. We are using this technology on our campus. Our all the filters, we can assume campus having three filters. So all the filters is using this technology. We are using UV tubes, and then we have some filter candles, initial filter candles for uh, pre-filtering to like sedimentation candle, carbon filter candle is there. And then only we are using the UV light. We are not using any RO type of thing, any RO membrane kind of thing. So no need of maintenance, no need of means the wastage of water is not happening. So we conducted some workshops to our IBT schools to teach this technology. And right now, most of the students transferred their home filter. They replaced their home filter with this technology. These are some organization. This one is the Gurukul Ashram in Pune. We deployed that filter system to there as well. So this one is the UV filter. We are working in drinking water technology. Then next thing is composting, again waste management. So if you see agriculture sector, and then if you see agriculture waste, there is so much agriculture waste. If you see sugarcane farm, there is so many agriculture waste generates that farm, right? And most of the farmers, what does they burns whatever the residue is there. Okay. So if you see Haryana and Punjab region, Delhi air pollution is most of because of that, because they burns all the sugarcane waste, and then it goes to the that smoke goes to the Delhi region, and then it affects to the entire three states. Okay, so instead of that, if we on another side, if you check organic carbon value of our soil, then it is continuously degrading. And if you see the organic carbon in this sugarcane residue, this is too much. But to convert that or to decompose that is the problem. So that's why we develop some composting solutions for this thing. And then again, we collaborated with the Pune University and the Department of Science and Technology, given us some funds for this. And this one is the some test beds with the farmers. So this one is the 1 ton bed. This lady in yellow, she got a grant from the DST, and then she tested her solutions with these farmers. So this one is the consortium she developed, microbial consortium she developed uh, through the Azolla. Azolla is again the one of the algae, and through that plant she taken out some of the bacteria, and then she made the solution of that bacteria, and then she made this agro waste decomposer solution. And now she tested around on 116 composting beds. It is around 170 ton, 170 plus ton. She treated that waste, and then she converted around 120 ton good compost out of this composting solution. So this one is the again one of the thing we are having a microbiology and the soil testing tissue culture set up on campus. So we are doing some of these type of experiments as well. So these are the areas where she implemented that experiment, and these were the locations she identified on this map. She just spotted that things on the map. So around 170 tons of biomass she converted in uh, good compost. So these are the demo plots and some of the photos of that process. Then we are working on home composter as well. So this one is the one of the prototype developed by our DIC student Akshay. So the this one is the that Akshay came for the internship in Vigyan Ashram, and after that he work on this composter. So what it does, it takes kitchen waste, and then after 20 days it converts that into the good compost. So it's having a this composter is also having a bacterial solution into that. So right now we transfer this home composter technology to the one of the organization in Pune, which is working in waste management. So Greeny is the organization name, and right now they are making a branding of these composters. So name of the composter is Aksi. Because of that, Akshay work on that. He left after completing his internship, but we continued the research, and after that we came up with this product, and now this green organization is selling this product on Amazon. These are the advertisements they are making. Again, same technology we transfer to the another lady. So she's a Pavni Lolla, and she's having a Vapra. She modified that name to the Vapra, and then she's also selling this type of technology to the again on online platforms. This one is the another composting model. This one is the society composters for the bigger version. If you are having a society with 30 to 40 flats, then you can come up with all the waste, and then in society you can make some compost out of that. So this one is the society composter models, and to filter out that compost, these are the some of the instruments we develop in Vigyan Ashram. So again, DIC students work on these technologies, and we tried these all these things on society, different societies with different municipal corporations. One of the project which is highlighted in Saswat Nagar Parishad. So this one is the Saswat Nagar Parishad's letterhead, and then they got that compost. They developed that compost brand. Whatever kitchen waste is there, they process that waste into the compost, and then they made a branding of that compost, and after that they got some brand Harit Compost kind of badge of to that compost, and they covered this news. Some newspapers covered that news into the newspaper. Then we are working on Wikipedia also. So we are developing some of the content, whatever technologies, whatever uh, curriculums, whatever knowledge we are having in our books, uh, in our traditional things. So we are converting them into the useful resource. So there is a one site, Wikipedia Marathi. So there is a big project. It's a Wikipedia Foundation, and Wikimedia Foundation is there. So Wikisource is also there. So the girls from the village, from the Babel village, in Babel there is one college, art science college, art commerce college. So girls from that college comes to the Vigyan Ashram, and they develop some articles. They write some articles on their related to their villages, different technologies, different on different books, and they are converting all this information into the. They are putting all this information on online platform. So this one is the scanner. That scanner scans the old books from different Marathi writers, and then we're putting the PDF formats of these books on online platform. So again, we're generating some of the knowledge through this Wikipedia project. So finally, these are the sustainable development goals. Around 17 goals are there, and 169 are the major targets. So Vigyan Ashram is working in this type of goals. Uh, I told about the dryer and then the reduce the food wastage. So is the one of the where we're working in that zero hunger is one of the sustainable goal, and to meet that we are working on this type of projects. So hydroponics, hydroponics, AI in agriculture, agriculture automation. So there are so many projects where again this is not listed here, but there are another projects also which are ongoing right now. So we're developing things, these technologies to meet this goal. Then another goal is like clean water and the sanitation. So if you see, we are working on grey water recycling, and then we are working on water filters. So these are the again towards this sustainable development goal. Then we are accepting some of the modern technology like AR, VR, 3D printing, laser technology, Fab Labs, and then Design Innovation Center, design thinking approach. So again, economic in terms of economic growth, where we are going through that. And then these are the some of the things like zero hunger, quality education, clean water, and then decent work and the economic growth. So these are the some government initiatives. But along with that, we are making our efforts with developing some rural technology and deploy that to the community level. So uh, so these are the things I want to talk about because we're working continuously, and there are so many projects we are developing currently. We already developed so many things. We deployed, we tested, and then some of the projects are failed, but some of are still good in good progress. And then most of the rural communities are using that, and uh, they become helpful for increasing their livelihood. So if anyone wants to visit, anyone wants to check our things, so these are the some of the websites, veganashram.com. You'll get all the information about our courses, and then short trainings on this website. The DST Tara is a collective website from the DST department, and then those organizations who is getting support from DST, Department of Science and Technology. So like vegan ashram organizations. So they kept all these their technologies on this website. So all these technologies are very applicable to the rural community because all these organizations are working in rural areas. And then Vijnanashram.online is our online exhibition website. So most of the projects we kept there. So you'll get initial idea of that project. And if you want to go in detail, then we have blogs on each project. So uh, we have documentation, we have records, we have testimonials, all these things we have documented. So we have blogs. So if anyone wants any detailed information about any project, then we can provide that links, and then you can see the experiments we did on our campus, and then how we are implementing with the uh, our customers or some rural peoples. So thanks again for giving me opportunity to introduce all these things to with you, and suggestions and some questions. We are now open for the discussion. So if you are having any questions, then uh, I'm ready to answer. I'm happy to answer all those. Thank you.
Yeah. So I have given all the participants. You can unmute yourself.
Uh, so I covered all the things, sir. Now we
Yeah.
are
Yes. Yes, sir.
questions.
Dear participants, if you have any questions and if you want to ask, please unmute yourself. Or you can put your questions in the chat box.
Yeah. If anyone wants to ask anything related to any project or any initiatives we made, so it's open. I kept my number and then I'm sharing my screen again. Uh, if anyone wants to reach out to us, then this one is my number, and then this one is the email ID. So you can write us for anything. If you want to make some collaboration, or if you want to know more about some of the technology, then you can definitely write to us.
Sir, there is one question in the chat box.
Okay.
Can you please suggest how a computer science researcher assists you?
Can you please suggest how a computer science researcher assists you? Most of the things we are working in hardware thing, but right now we are working in AI. We started working in AI. Right now we have some of the projects, like one of the project is like we are developing pest prediction system for the foliose farmers. So we are collecting some of the data and we are developing some mathematical models right now to generate the notifications for the capsicum crop. So this type of projects we have. We are also making our campus a little bit digital. Means we are developing some IoT platforms and then some dashboards for our hostels, for our campus, for our kitchen, to make visible the energy consumption, to make visible our uh, different like carbon footprint, if we say. So how much carbon we are generating on our campus, and how we are tackling with that. So this type of dashboards we are working now right now. So computer science researcher, yes, if you are having background in some developing developer kind of skills, then this is possible to assist us in terms of like front end developer, back end developer kind of thing. Is the same thing you want to ask, sir?
Okay.
Yeah.
Is there anyone who would like to ask the question? I think we do not have any questions from the participants. So if there are any questions in the chat box, I will collect them. So it is a wonderful session by Mr. Suhas Lavre, sir. Vigyan Ashram is doing very great work to provide a different cutting edge technologies to the society through various projects. Where, sir, are you there?
Hello, sir. Thank you, sir. Hello.
Yes, sir. You are
So,
audible.
thank you very much, sir, for accepting our invitation and delivering very wonderful and social topic that we have taken efforts for this. On behalf of our CSMSS family, I thanks to you, sir. Thank you, sir.
Thank you. Thank you. Thank you very much.
Yes.
And thanks to all the participants.
Yeah. So now we'll end this today's session and we'll move ahead with the second session, sir.
Okay, sir. Thank you.
Yeah. Thank you very
I'm
much.
leaving now. Okay. Thank you.
Yes, sir. Thank you. Kanchandani, sir, are you there? I have given you a right as a co-host. Hello. Dr. Kanchandani, sir.
Hello. Hello, Praveen. बोल ये बोल रहे हो हाँ एक मिनट
Yes, sir, you are audible.
Praveen sir,
Yes, sir.
sir has joined, I think.
Yes, sir. Yes, sir. I have given him a right to share his screen.
Okay, okay.
Okay. Now they are shared. Sir, will you please make it in a full
Cool.
screen mode? Yeah. Your
Hello.
slides are
Why-
clear, sir, now. Yeah.
Clear, na?
Yes, sir. Yes. Sir, your voice is too low.
Hello. Very good evening to one and all.
Sir,
Am I
just a
audible
minute.
properly?
Sir, just a minute. Your video, okay. Sir, will you please try to change your slides? Yeah, it's changing, sir. It's yeah. Okay. So, good afternoon, all of you. Now we'll move. Today we have a very great personality with us who is going to deliver this session on how the deep learning can be used for the crop disease prediction. So we have expert is Dr. Kamlesh Kanchandani, sir. He is working as a professor at Department of Electronics and Telecommunication Engineering at Sri Sant Gajanan Maharaj College of Engineering, Shegaon. He has done his PhD in MIT Bhopal in the year 2006. He has more than 35 years of teaching and administrative experience. Along with that, he has guided more than 8 students under him for the PhD. His area of interest is artificial intelligence, machine learning, and deep learning. He also worked with the low power VLSI design and signal processing and computer vision. To his name, more than 150 publications are there from different conferences and journals. He is well-known author of the book Power Electronics, which was published by McGraw-Hill Education. As I do not want to waste much more time because we want to listen to him how deep learning can be integrated. So I request sir to start with his session. Sir, please.
Thank you, Dr. Praveen Wankade, sir. So I am first of all thankful to the authorities of your college and especially my uh, ex-students, you can say, Dr. Bhuyar sir and Dr. Wankade sir for giving me this opportunity. So, guys, myself, Dr. K.B. Kanchandani, I am here to just put my knowledge, you can say, or my views, ideas related to deep learning, how deep learning can be used for detecting the plant disease in the agriculture. These are the various points I will try to cover in this my presentation. So we all know that the global population is highly increasing, especially in India now first of all, and then the China. So India is now more reluctant to this population problem. And very recently, the report has been published by Food and Agriculture Organization that by the year 2050, the world population will be around 9.1 billion. And more than 25%, 30% around, you can say, will be the India's population. So if the population grows at such a tremendous rate, then obviously problem related to the foods will be there, which will be faced by the society. So therefore, it is highly necessary to maximize our agriculture production. And we all know that day by day, there is a less interest in the farmers also from the rural areas. The new generations, they basically don't want to work in agriculture. They want to upgrade them with the technologies and they wanted to become doctors and engineers and likewise because they think that the society is giving more weightage, more respect to them compared to the farmers. And because of this tremendous problem, definitely if we will go with the if we go with the agriculture process by following just traditional methods, then definitely we can't produce the required food for our rising population. Hence, there is a need of the hour that we should automize, we should develop our agriculture with the modern technologies. We should apply all the modern technologies to the agriculture for enhancing, for increasing the food quality and quantity at the same time. The answer is simply in one word is the precision agriculture. Precision agriculture, I hope you might have studied or you might have listened to many speakers previously. They might have focused on it, what basically a precision agriculture is. So in short, it is a agriculture agriculture process which uses digital analytics, and digital analytics means by using a very high technology sensors, IoT sensors, so many controllers, drones, and means so many database devices and networks. So by using these all modern equipments, devices, technologies, we can definitely increase or fulfill the food population requirements by 2050. Now, just I will highlight here the problems of present traditional methods, especially from India point of view, because in India we don't have moved to you can say by uh, smart agriculture process we are not following right now. Very small percentage you can say is there. So traditional methods which farmers are using for especially disease detection is they observe that diseases in especially related to plants by their naked eyes. They observe those diseases manually, you can say, which is a very time consuming and definitely it requires a very expert knowledge. And especially if the farm size is very large, then definitely no one can do this a very perfect manual process also. So needs a lot of helpers, workers for observation also. So and during the observation also, because of the limited knowledge, or even though the knowledge may be maximum, we all know that day by day the diseases produced by so many effects are increasing, their rate is increasing. So manually or by naked eyes, not possible to detect uh, the plant diseases which are error free. So that's why there is a need of the hour. We should apply our artificial intelligence techniques and methods for this detection purpose. Why we should detect? Because if the disease, crop disease, plant disease are not detected or our crops are not protected from it, then definitely there will be the losses which a farmer will face, and definitely it will affect the quality of the product as well as the economy of the farmer, and as well as lastly it will affect the economy of the country itself. And we all know that in India, our economy totally 70% totally depends on still in on agriculture. So in short, now what I want to say here is early detection of these diseases is very important. Detection as well as controlling and prevention of these diseases is very, very important to fulfill the needs in terms of the food quality and quantity, and as well as improving the farmers and enhance country's economy. So just I shared here that we should focus on now by applying the smart technologies to agricultural field. Guys, you all may be knowing right now that Israel, a very small country with a very less population, even less than 1 crore, they are not only fulfilling their needs, but also exporting their agriculture products. And since they don't have the people for doing the farming, they have almost, you can say 100%, you can say now, they have automized their complete agriculture by applying IoTs, sensors, drones, AIs, and especially nowadays they have added blockchain technology also. So their farms are highly flooded with the data, and if the data is there, a huge data is there, so definitely to carry this data, to process this data for generating the required results, we need a strong networks, and the answer is the deep learning. Why and how, that we will see definitely. Now, drones, also our Indian government, you all might be knowing, has certain policies related to supplying the drones to the agriculture with larger acre sizes. Because with the drones, a lot of information related to crop health, there are problems, farming problems, all problems can be recorded from larger distances and at a high rate with very strong sensors, with high resolution and images. And definitely the processes can be developed, and again the target is again the target we can achieve is, that is food quality and quantity. So Indian government has taken so many efforts, but yet there is no required efforts in India. At the same time, in foreign countries, I told you, in Israel, North America, Netherlands, and certain portion of Brazil and Canada also, they are following all these techniques, and they have added recently blockchain technology concepts, because of which they are getting authentic foods at their tables directly from the farm. So in this marketing business of agriculture, the blockchain technologies are widely used in those countries. And in India, we also need these things. So I shared with you why we need automation. And so automation basically results in basically accuracy from detecting a disease from the plants. And I also told you right now, nowadays, if we do automation, we can have a lot of data from sensors and so many other devices. And to process this data, we need a strong networks. And the answer is the artificial intelligence, where we are using machine learning and deep learning as a solution to these networks. Machine learning, all might be knowing that is a subset of AI, which is totally based on algorithms, which is capable of identifying hidden patterns in the data and self-improving their performances. Widely available algorithms you all are knowing are SVM algorithm, that is support vector machine, k-nearest neighbors algorithm, ANN-based algorithm, k-means classifier. So many algos are available there right now under the category of the machine learning. So here, but from agriculture point of view, guys, machine learning is not the proper solution because we are having the data. Is in the form of the images, and when the data is images, machine learning is not producing the perfect results because it is more effective on the tabular data. And when we transfer any image data into tabular form using any of the method, we are losing some information. So data may not be accurately available in tabular form from the images, and hence there is a limited scope for machine learning in the field of agriculture. So definitely we need to now focus on the another subset of machine learning, which is nothing but the deep learning. Just briefly, I will provide you what is deep learning. It involves the neural networks with multiple hidden layers to handle the image data because it is capable of learning to classify and detect a region of interest. Because of this great feature of the deep learning, the deep learning has 100% scope for automizing our agriculture. And one part today we will see is how deep learning will be used for detecting your diseases. Deep learning definitely can be used for robust and scalable solutions. How? Answer definitely you will get at the end of this presentation. Also, guys, your computer vision tools recently are available, which are which are also been used by the foreign countries for this purpose also, because they have pre-trained models, and pre-trained models basically improves the accuracy and so many performance parameters which are considered while detecting a disease. So that we will also see here. Under the deep learning, various neural networks structures are available, and it has been concluded in so many research papers that CNN is the best one for that because of its deeper layers and increased accuracy. So now it's a duty of the all engineers to and the government and everyone, biologists, agriculture universities, everyone to focus on the deep learning based, you can say, or AI based in short, the agriculture to make the life of the farmers happy and wealthy. Now, just briefly, I will provide you about the knowledge about the diseases, especially plant diseases, because if it is known to us, then and then we can design and develop our solutions very properly. Plant diseases broadly are decided or divided in two categories: abiotic diseases and biotic diseases. Abiotic diseases basically are the diseases which are caused by pest, sprinkles, and other related your weather conditions in the agriculture. The biotic diseases are simply the diseases caused by viruses, bacteria, and fungi. The fungal diseases are generally present in a wide range of vegetables and cause severe damages to the plants. And similarly, the viral diseases are parasitics that require living host for multiplication and growth. This damages crop yield and causes significant losses to the farmer's economy. Just a simple one picture here. We can see for the plant leaves which are infected here. So these are the infections with these leaves. These are the infections. This is the infection. This is infected one. This is infected one. So mostly there is always a chance that the plant will suffer from the diseases. The leaves will be suffer from the diseases. So here is the briefly a classification of these diseases I am providing you: biotic and abiotic. Biotic are classified again as spring frost, weather conditions, burning chemicals, whereas abiotic types are, I already shared with you, are bacterial type, virus type, and fungal type. Bacterial type are again classified as subclassified as spot type, wild type, soft spot type. Viruses are dwarfing, distortion, bottling. Fungal types are molds, cankers, blights, mildew, and rots. So this is the disease of classification, plant disease. Now, the bacterial disease basically symptoms, as I shared with you, is the cankers, the overgrowth of plants and scabs. Scabs observed mainly in the your apple and leaf spots. The symptoms of the bacterial diseases are usually very much similar to the fungal diseases. Plant diseases affects hence the quality of legumes, vegetables, grains, fruits, and causes severe production losses, that is economical losses. Fungal-like organisms or fungal mainly cause approximately 85% of the plant diseases, whereas viruses and bacteria causes remaining 15% of the diseases in the plants. The suspected plants normally shows various lesions or marks on the fruits, stems, flowers, and leaves also. Potatoes, tomatoes, we can observe them in a regular life also. So definitely there is a need to focus on the detection of this your diseases, and you have to examine the plant leaves all the times. So here I am covering a brief about the crops and common diseases available. So crops types we can classify here as cash crops, fruits and vegetable crops, food grains crops. Cash crops like cotton, tea, coffee, and here in this category, the your viruses or your diseases will be cotton leaf bacterial blight, Altimeria type, Serispora, grey mildew, algal leaf spot, grey blight, white spot, brown blight, red scape, bud blight, and grey blight. These are the different names of the diseases observed under the cash crops, especially cotton, tea, and coffee. Second category of the crops, fruits and vegetables. Fruits mainly here considered, I have considered apple, lemon, grapes, cherry, banana. Vegetables, especially the tomato and potato, cucumber, and the diseases observed are marsonia, apple scab, powdery, mildew, downy, mildew in grapes, banana leaf, bunchy top bacteria, while black cigarette, apple black rot, cherry powdery, mildew, citrus, black spots, melanos, cankers. So these are the various diseases observed in fruits and the vegetables. And third category is under food grains, corn, rice, wheat, soya bean. And here list is also provided for these diseases here. So rice blast is there, bacterial leaf blight is there, shell blight is there, corn grey leaf spot is there, likewise. So these are the diseases and observed under the various categories of the crops. So to detect this particular diseases, we should have a suitable detection system. So here, just brief, no, generalized detection system I am showing you here. That is plant disease detection system. And it is very simple. This is the simpler form of this detection. Advanced versions I am sharing with you in my 3 different experimental processes. So here, broadly, we can divide any detection system, plant disease related especially, into 2 phases: training phase and the testing phase. Training phase, as being an image processing students, you might be knowing it consists of image acquisition, pre-processing if required, then segmentation, feature extraction, then recognition and classification. So these are the things which we need to consider under the training phase. Whereas in the testing phase, basically we have to test the data which we received from the training phase. So we have to validate the data first. So validation is its important first stage, and testing is the second important stage. Under the training stage, the collection of images are used in the network to automatically learn hidden parameters. This is the main role under the training stage. You have to collect the images, then you have to use the networks to automatically learn hidden parameters such as biases and the weights. Network students might be knowing everyone or faculty members, those who are teaching the networks or those who are doing the research in the computer networks or artificial intelligence networks or neural networks. So under the training stage, you have to focus on mainly the biases and weights. And under the second phase, testing phase, you have to focus on the validating the data, and you have to focus on the training the model, whether a model is properly trained or not, because it is going to decide whether the output is in infected output, healthy output. So related to this general process, I'm going to present different experimental setups afterwards. So guys, I shared with you that either we have to use machine learning based techniques or the deep learning techniques. So here just I wanted to share with you, but I should told you right now that there is a limitations on the machine learning algorithms from plant disease detection point of view, because the data is available in the imaging form, and machine learning algorithms, they don't provide more than 80-85% accuracy uh, in such cases, because they need the data in the tabular form. So for during the conversion from the image to tabular, mostly the accuracy, efficiency, and other performance parameters get reduced. Even though if the size of the agriculture is less, I mean very limited, 1, 2, 3, 4 acres, in that case we can think of, because in that case then the cost is playing a good role. So machine learning algorithms are cost competitive, and if the data size is less, we can think of it. But again, there is always a criteria that is based on performance parameters and the cost. Somewhere you need to compromise. Okay? So after discussing the performance criteria factors, we will conclude with this one. But right now, I can tell you, we will not getting more accuracy in ML-based algorithms. Here, I am providing a summary of this machine learning methods, broadly classified as supervised learning, reinforcement learning, semi-supervised learning, unsupervised learning. Supervised learning in the category is the first one is consideration is the classification, regression, and under the regression concepts, the random forest, decision tree, linear regression, gradient boosting tree, and neural networks. These are the various algos under the regression. Now, mainly under the regression, and especially the linear regression concept is widely used for prediction mainly. So linear and polylinear and other linear regression problems or algos you can use for forecasting or for detecting, especially the here for predicting the noise levels over here. Under the classification categories, we do have available native Bayes kernel, linear regression, KNN, neural networks, linear SVM, logistic regression, decision tree as the basic algos. Now, under the unsupervised learning, we are having dimensionally reduction concepts and clustering based concept-based algos. So singular value decomposition, latest Dirichlet analysis, PCA-based concepts. Whereas under clustering, we are having Gaussian mixture, hierarchical clustering, K-mode and K-means algos. So depend upon your expertise, you can think of the suitable algos, but regression regression based will provide you, I think, the more accurate performance parameters for especially detecting the plant disease and especially when the your farm size is very less. Now, our attention will be now more focus will be on deep learning. So, deep learning, brief just I will provide you here. We all know that it's a subset of machine learning which uses neural networks. The main key characteristics are the main key characteristics which makes useful deep learning for agriculture disease detection are feature learning, which extracts relevant features automatically. This is a great and very important feature of this deep learning. And because of this, we can extract the relevant features automatically. And we need to automatically extract the features from the plant leaves with used data. Second, we need a highest accuracy. So it excels in image and pattern recognition. Deep learning, because of its structure and the working behavior, we are getting a very good accuracy from this data available in imaging and pattern forms. And we are data driven basically, and just we focused on what if we want to increase the quality and quantity of the food in the agriculture, then we have to optimize our agriculture sector completely or agriculture industry completely. And automation means data driven. And definitely, if the data is available, we need the networks to process that data for generating the results. So larger data sets will be available, and deep learning networks is the solution to handle these larger data sets. That's why the focus is on deep learning, making a use of deep learning in agriculture. Popular architectures, I just told you, CNN is the best, which is already concluded. And nowadays, attention has been given on certain hybrid build structures, which I am going to tell you in one of my experimentation. So CNN at particular scenario, at particular when the situations you need to use, and or you need to use certain hybrid structures for certain cases, certain situations that I will conclude at the end. Right now, just is not only to make a use of deep learning for detection of plant disease in agriculture, we can make a use of deep learning for completely optimizing our agriculture. Here in this, you can see, first here you can see is the field condition management for managing the field conditions, that is for managing the soil health, for managing the water management, which are the two important aspects of the any agriculture, which decides your quality and quantity of the crops or food, you can say. So here deep learning can plays a very vital role. Second, if the product is there, definitely if the livestock is there, we must have certain management for management is we need some management. In India, especially in states, we are getting the news that in so and so stage, huge stock of the uh, your grains, crops has been destroyed due to heavy rain. Likewise, so definitely management of those stocks is again a very important issue where deep learning can help us. Third, under the crop management, which is the topic of our presentation. So here monitoring of the crop, detection of the diseases and weed control, these are the three main factors which can be considered for crop management. And this we can nicely do, more accurately do with the help of deep learning. Then weather forecasting also. Nowadays, your advanced countries are using this one already for forecasting the weather because weather affects the agriculture. And lastly, for precision agriculture, it solves the problem mainly related to the humans. So, because just we everyone know that there is a huge shortage of laborers in the agriculture, and because of the so many schemes also we all know provided by every state. So huge shortage is faced by nowadays in the agriculture industry. And at the same time, we need certain agriculture chatbots, which will definitely make the life of the calmer, happiest, and coolest one. So, conclusion, we need AI or deep learning in the complete field of the agriculture to make it automized. Here is certain, again, the points are provided here. So, deep learning, especially now in agriculture, for disease detection, yield prediction, crop management, water management, soil management, weed detection, and for counting also, here added one. So, fruits counting, which is very essential. So, especially fruit counting is very essential. So, that can be nicely done with the help of deep learning. So just will provide you a brief of the deep learning architecture here because not possible to cover the details because I will be again focusing on three experimental setups. So here briefly provided the deep learning structure which consists of your multiple convolution layers here multiple convolution layers it consists of various pooling layers. So here convolution layers are given here. Certain pooling layers are also shown here. And third type of the layer, which is termed as fully connected layers. So this is a generalized architecture of your convolutional neural networks, especially. So CNNs are widely used for a variety of applications such as object detection, image classification, voice recognition, image fragmentation, medical image analysis, text and video processing. So for all these applications, this structure of the CNN helps nicely. The convolution layer basically is the most fundamental here you can see because it's forming a base for this structure. So, and here we are having a huge data here. So data may be of different types, more and more different information. The size will be more. So convolution layer helps in storing this data, huge data. It because storing of huge data is very important along with the different informations available in because if suppose we are having 1,000 news here and some are infected, some are not infected with viral disease, some are infected with bacterial disease, some are with other problems. So data will be used and at the same time the different data will be there. So definitely there is a need to store that different data with huge size and convolution layers are the strongest component of this CNN which helps in storing your this particular images and images along with their different characteristics. Pooling layers. What is the role of these pooling layers? These pooling layers, what they does, they basically generates the aggregate of all the different dimensions of image first of all, and then they recognize the object. Even though if suppose distortions are available or certain the positioning of this data or image is also not fixed, they are put at different angles even also. The pooling layers are able to generate the aggregate value of all these different dimensions. Because of this great feature of this your pooling layers, the learnable features in the model required will be less because of this aggregation of all these values. Even though the distorted data or not proper placement of data is available, because since it is able to generate the aggregate of that, so definitely we need a minimum. We need lesser features which needs to be learned by our structure. So it reduces basically, you can say, the weightages bias and you can say the complexity of a network also. So the different pooling structures or layers are used. That is average pooling, maximum pooling, and stochastic pooling. So depend upon our requirement, we have to focus on it. It's a separate detailed topic, guys. So you need to focus on this as per your requirement. And third layer is fully connected layer. fully connected layer here, which is basically you can see here in this diagram, we are showing here again the data input, the convolution layer, the pooling layer. Here, the third part here, the main part, output layer, you can say, or fully connected layer. It is shown here. It is divided into two different layers, you can say, as a dense layer and the output layer. So the input to this dense layer, you can say, is available in the flattened form. Okay, so flattening input is available to the dense layers, and final output is generated from the output layer. So combinedly, they are termed as the your fully connected layers for CNN. Now, fully connected layer is the final layer, which is used to fit the neural network. So this is about what? A network which you have to design now as per your application requirement. A generalized network diagram, then how many layers in the convolution, how many in the pooling, how many in the output, that you need to design as per the application area, application task, the data, and so many factors will be there, which is going to decide the types of the layers and other thing. Because designing of CNN is a separate topic now, guys. Okay. So just here, you can either use a basic structure along with your design capabilities, or you can use now, this is the great feature available nowadays from this architecture point of view, that is pre-trained architectures. Several pre-trained architectures are available, such as VGG16, VGG19, ResNet 50, ResNet 152, Inception V3, Inception Edge, DenseNet 121, and so many also, because I have not put everything over here. So many pre-trained architectures are available, which makes them very useful for this purpose also. Now, regarding convolution layer, which you need to decide, the first job is to produce the activation map by scanning the several pictures with several pixels at a time using a suitable filter. Okay, so here is the image with so many pixels available here. So we have to decide the kernel, that is filter size. Here 2 by 2 is used over here. So here is the pixels available in the image. Based on this now, we can generate the activation map, which is required, which is produced by your convolution layer. So here you can see ABEF is, you can say, one group, and which is filtered now with the components WXYZ. So here it is showing as AW plus BX plus EY plus FZ. In such a way, this activation is prepared. The second layer is the pooling layer. So I told you already, the pooling layer basic role is to reduce the amount of the data basically. And because of this reduction in the amount of data, the data becomes highly efficient, and hence the CNN layer, you can say, can be properly or efficiently designed because of this pooling layer feature. Now here is the internal working. Simply briefly, I am providing you. So here pooling layer is shown here. Now what we are doing here, we are doing the max pool, which by this 2 by 2 filters and by strides 2. So what is the meaning? Here, suppose this is the size of our pooling layer. So here you can see single depth slices we are taking here. From this now, the maximum component is this one. From this, the maximum component is this one. Here this one, and this one is this one. So here the result is what? 2 by 2 filters and with strides of this 2. Now filters and stride size, remember guys, from the design point of view, they must be always your same value. They must be always with your same value. So basically, what is this activation map and what are or this activation map? They are termed as your feature maps also. They are also termed as your feature maps. So basically, these models are comprised of small linear filters, and the result of applying these filters, as we see, these are the filters, and by applying these filters results on the image generates the activation map or the feature map. we can obtain this detailed activation map nowadays. The people are using mainly all researchers are using now a concept of what guided backpropagation in connection with the GRAD scam, GRAD CAM. So guided backpropagation in conjunction with the GRAD CAM concept, or in short, it is termed as guided grade GRAD CAM. So this is the approach basically, a concept which is nowadays used to get the activation map or feature map. Feature, FEATUR. Feature map is a map which consists of features of the your data or the image in the plant quality or 100% okayed leaves. So that data is available in this now activation map or featured map. I hope you might have got the concept of this activation map. So just remember guided grad can concept. You study that concept because guys not possible here to cover everything in detail in this short span of time. So here I'm trying to provide you overview of my work so that you can get the idea how to implement the systems. So now third part is the fully connected layer. So in the previous diagram or here also you can see here in the first diagram we saw it's a fully connected layer, which is where the first part is the flattened part, that is flattened output is available there, and because of that we can turn them into a single vector, and hence it's used as an input for the next stage. Because if a single vector data is available, then it can be easily processed in a short time and makes your network a faster one and faster one mainly. So here we are having the two your networks. The first fully connected layer, as I already told you, whose job is to add weights and bias to the inputs from the feature analysis to anticipate the proper label, and the second layer to generate or to offer the probability for each label in the end, or to generate the desired data in short. So this is about the generalized structure of the CNN. This is just brief I provided you guys. You need to work on design and development of this all three parts of the network along with their weightages, bias, and so many your concept. One concept I told you just now. Go with the guided grad CAM concept for getting the activation map. This is very important. So now this is designing your own CNN for the task. Now, otherwise, you can also use already trained structures available. So, trained structures, the list I provided you in my previous slides. Here one is the VGG19. So, it is a CNN basically with the pre-trained layers. It is a CNN with pre-trained your layers. So, now, these names, VGG19, VGG14, all these are basically depends upon what? The size of the layers, basically. The size of your layers. So, VGG19, so here you can see, is constructed here by your layers. These gray color layers at various locations are shown as a convolutional layers, as a convolution layers. These red one are your max pooling layers. Then your blue one are your fully connected layers or flattened layers. The yellow one are your fully connected layers. Here green one, and here your this light blue, you can say, is basically a dropout concept used here. So all these points are shown over here. So VGG19 basically is a variant of VGG model, which in short consists of, now I am providing you the data. You can write this. Convolution layers consist of 19 layers. total layers consist of 19 layers. 16 are convolution layers. 16 are your this total convolution layers. First point. Fully connected layers are 3. Fully connected layers, this one, total are used in this structure. Pre-trained module is your number 3. Max pool layers are 5, and one softmax layer is internally used over there. Okay. So details not possible to cover here about this one. So this is one of the just I wanted to share with you, guys. We are having now already trained networks, and this is one of the example. Now here I am providing you the complete flow for implementing the deep learning models for our work. Okay. So here, first of all, as I shared with you, we are having a suppose the plant leaves. Okay, different plant leaves we will be having. Based on those leaves, now we will be having the images which forms your data set. Now, once we got the data set, we have to split the data. Second step. So we have to split the data. Now, splitting the data basically in two sets, the training set and validation set. So we have to divide the complete data in two sets, training set and validation sets. Once we are having this data division, we have to handle them very separately. So for that now, as I showed in my CNN structure, we are having a training part and a validation part, that is testing part. So that the data needs to be provided to our architecture, deep learning suitable model, a trained one, a newer one which you wanted to design. Okay. So frameworks you can use either AlexNet, VGG, ResNet, etc. also. So once you are able to design your suitable network, you need to train and you need to validate your model which you are selected or which you are decided, and from it you have to generate the various results. Okay, you have to have a checking of the accuracy. What is the accuracy plotted for per epochs? Then you have to validate that accuracy. You have to measure the training loss, how much loss has been there in the information during the training. What is the loss during the validation? These are the performance parameters you can say. So that you need to measure, and that data which is available, you can say in a tabular form also, can be shown graphically or can be plotted also. Okay, so here we will be having that discussions or that results over here, and from the same also, from that output also, you can generate various performance parameters. Here I am showing you two more, we will discuss later on. So like F1 score and accuracy. So you have to generate the various performance parameters of your designed structure, and they are going to decide the quality of your structure or the results of prediction. The results you can graphically visualize by using a suitable visualization techniques, and the results are shown here. So here you can see this part is the infected part of this particular leaf. So this way you have to follow this complete structure or various steps to generate the desired results. So here briefly I mentioned here. So first of all, data collection. So image data will be there. So for this, we have to use high resolution images of the crops. First point. Added data will be definitely you have to consider is what? Environmental data, because sudden rain is there, temperature is there. Image data here, high resolution images of crops will be there, and the related added data will be what? The environmental based data, because sudden raining, increase or decrease in the temperature, pressure, humidity, all these parameters which basically affects the quality and quantity of the crops, we have to consider as a data. So image data and the environmental data, we have to collect them. first of all. That will be always our first step. Second will be the pre-processing of this data. So image augmentation, you have to do for this first one. If required, you have to move for the normalization. And the third, you have to go for the labeling of this data. So these three steps you have to mainly carry out under the second process. Third process or third step of design is your model training. It is the main one which decides the performance features. So you train your CNNs with these labeled data sets. You have to use the suitable training structures, training ideas, training. You have to apply your complete mind over here for getting the desired results. And finally, the prediction and the deployment of your whole process. So real-time disease detection, you need to carry out either on the cloud in the data, and if you are handling your huge size of the agriculture, or edge devices like computers or your mobiles if you are doing some experimentations. Now, regarding deep learning, so different improvements in the CNN structures are taking place regularly, and this can be classified under the parameter optimization. By what are the different parameters optimizations, what are the regularization concepts, and what are the structural reformulations. So normally the improvements nowadays in a CNN is based on this your three aspects: whether the parameter has been optimized, whether it has been regularized, and whether there is a change in the particular architecture. And based on especially the architectural modifications, which is totally based on the designer's concepts, we can classify again them in four categories. Means we can divide the various structures of the CNN under the categories as special exploitation CNN network, depth-based CNN network, multipath-based networks, and width-based networks. And several implementations which are considered under every category is shown over here. Like special exploitation, here for under this, the several implementations such as LateNet, AlexNet, VGG, GoogleNet are classified. DepthNet, depth-based are ResNet, Inception V3, V4, Inception, ResNet. Multipath-based are ResNet and DenseNet, and width-based are Exception and Inception complete families. So deep learning classifiers basically are which are mainly used for disease detection are done on these four categories basically. Now, what is the frameworks we should use for implementation? So here I have provided you the conclusion. Framework, either you can use a TensorFlow that, or the TOY, ATAL, MATLAB Toolbox, and Keras. I will suggest you to go for the TensorFlow or the Keras because so many supported libraries, strong libraries are available with this tool. So either go for the TensorFlow or for the Keras. You can use the Python as your programming language for implementation purpose. Operating system, definitely Windows and Linux are there. So for handling limited data, Windows will be okay. But for huge data, you need to go with the Linux always. And guys, mostly they are the open sources. So frameworks are open sources mainly. So you can go with this one. Now, briefly again, I will try to discuss with you the three experimental setups. I think 30-40 minutes are left. We'll try to cover all maximum points. So here, a basic idea I'm providing you here regarding how to use or how to develop a CNN algorithm to detect disease in the plant leaves with the maximum accuracy. So previously, I explained you the different steps. In short, also I provided you the conclusion of developing your complete your CNN based design for detecting the disease disease from the leaves in the agriculture. So just follow this processes, apply your whole knowledge at the different levels and get the desired results. So first step is your data set always. So always there will be a question how to get the data set. So different sources are there. You can have a plant village data set. You can have a plant doc data set where you will get the detailed plant disease data. Now here in this experimentation, the plant village data set consists of 54303 healthy leaves and unhealthy leaf images, which are divided again into 38 categories by the species and the diseases. More than 50,000 images of plant leaves with distributed labels from 38 classes are used to predict the classes of the diseases. Then we have to resize the image, and the resize selection is 256 by 256 your pixels, and optimization needs to be performed along with the model predictions on this compressed image, because once the compression is there, your so many characteristics get changed. So you need to optimize them again, and you have to model the predictions based on these resized images. So here is that data presented. The data set breakup is provided here. The different leaves, apple, cherry, grape, peach, pepper, potato, tomato, strawberry, and images number is also provided here. Here you can see the healthy, your apple leaf is likewise, and this is the infected one. Tab disease on the apple leaf. Similarly here, healthy strawberry leaf, infected strawberry leaf spot is the disease available here on that leaf. Then tomato healthy leaf is shown over here. These are taken from the data sets. And here, the tomato leaf mold is your disease. So these all are taken from the plant village. This data is taken from the plant village data set. Next stage is the data pre-processing and augmentation. So image augmentation, you all are knowing, it plays a very key role in deciding or developing a very effective image classifiers. So there are many image augmentation options available. One is the flipping the image vertically, horizontally, rotating through various angles, and scaling the image. This augmentation helps in increasing the relevant data in the data set. The size of each image in the plant village data set is found to be 256 by 256 pixels. The data pre-processing and image augmentation can be done with the help of Keras deep learning framework. I suggested you to go with the TensorFlow or the Keras. So with the Keras deep learning framework, you can do this, your augmentation, image augmentation. The other options are the rotation. You can to rotate a training image randomly over various angles. You can do this. You can use the Keras framework. You can the brightness. You can help the model to adapt to variations in lighting by feeding images of various brightness during training also. Because when we train, we have to consider the different brightness also. So, and third factor we need to consider is the shearing. So we can adjust the shearing angles also. So under the augmentation process, we have to consider these three features: rotation, brightness, and shearing. And there is the generalized again the system overview for this basic experimentation. This first one is the basic one. So here where we have to simply develop this architecture. So input image, image pre-processing, segmentation, then feature extraction, select feature values, do the classification based on the all databases, and then go for the prediction of the disease. The whole process now, again, here what we are doing now, explaining here the whole process. So input images are first created either by the Android device, suppose if the data is very less, or it can be uploaded to web applications by the users. First step. Second step, do the segmentation pre-processing, which includes the process of image segmentation, image enhancement, color space conversion. These three tasks we can do under this. So initially we have to, the digital image of the image is to be enhanced with a filter, first point. Next, we have to convert that image into an array, second point. And after that, we are using the scientific binary diseases, we can say. Each image name is converted to a binary field. So these are the three things we have to do under this. Then we have to mainly focus on now the main part, that is CNN classifiers. So CNN classifiers are trained to identify diseases in each plant class. This is very important. So level 2 results are used here to call up a classifier, which is trained to classify various diseases in that plant here. If not present, the leaves are classified as healthy. So level 2 results are used to call up the classifier, which is used for your classifying the various diseases in the plant. So again, shown here, the image data set, data, annotation, data augmentation, testing, training, validation, disease detection, disease training, then performance verification, and the result. This is the simplest process. So the result of this simple here has been observed on 400 images taken from the each folder. Each folder is converted to the array. Along with this, we process the input file by scaling the information points from guys questions I will handle at the end. Let me finish my presentation first because my remaining portion will be left. So definitely I will take your questions at the end. So we process this input file by scaling the information from 0 to 255 image. And so image minimum and most RGB values will be between 0 and 1. Then we will split the data set, 70% of the training images and 30% of the testing. So image generator objects are created based on this. Then we have to develop a standard model where we have to use a last channel architecture. We have to also handle the data sets also. So we have to build backend switches which supports first channel. So here we do the convolution. We are using the ReLU concept. You all might be knowing the ReLU concept, which is assigned to the full first your layer. So here 36 filters, full layer has 36 filters, and the filter size used here is 3 by 3. We apply batch normalization concept over along with the maximum aggregation with a 27% reduction. So these are the results obtained here. So with this pulling, we are getting a 27% reduction in the original data. Here the dropout concept is used, or you can say the control technology is used to reduce the neural network adjustment by preventing the correction of complex collaborative data for training. So this is the very important step, designer step you can say, or very effective method, which is almost used in every design of this CNN, even in your hybrid structures or very modern structures, by which it is possible to get the 100% accuracy also. So that accuracy 100%, wherever it is mentioned in the research works or in the products also, that is only possible on this factor or on this particular control technology, which is termed as dropout technology. So Now, after that, we have to create the two different sets. Okay, and here we have used Adams hard optimizer for our model. So this way, the model generator is used. Our aim is to add data, train, test the data, and the number of epochs we want to train. And for this simple project, we have used the epochs of 26 only. So here simply training and validation losses are shown here in terms of the accuracy and the epochs. So details, I will explain this in my next experimentation. Now, second experimentation, which I prefer more and is widely used nowadays, you can say, or if you are working on this, if you are doing research, I will suggest you to go for this because this is here I have used uh, the hybrid structure. Okay, so focus on this, guys. Most of the concepts are same, except the CNN structure. So here I am not going directly to use the CNN basic structure. And instead of that, I am just telling you about something about the your hybrid structure. So your input, then data acquisition, data pre-processing, this will be always same everywhere. Then this is the your hybrid structure, nested model. Okay, what it is and how to use it, that I will explain you. Okay, it consists of the the performance, you can say, depends upon this step, which is termed as training and multi-feature fusion extraction. What exactly it is, we will see in details about this. Then model evolution we have to do. Here, the concept we widely use is few shot learning concept. It is used there. Again, we will discuss about this all these 3 points in detail. And from this now, it is basically algorithms used here under this two processes, you can say. And from this, we have to generate the desired output, and it will provide you whether this leaf is healthier one or not. So in this, I will try to show you the potato and tomato cases. Okay. So again, the data acquisition. So data is taken for tomato and the potato leaves. Here, 2152 photos are available in the again potato village leaf data set is used here again, and 2152 photographs of the potato leaf disease are available in this data set. 11,000 photos in the collection for tomato leaf disease are available, and around 4,000 images in the data set for mango leaf are available. So here, everything summary I am providing you. Potato village data set, classes 3, size of the image 700 by 600, number of images 2152. Likewise, potato village data set, potato plant data set, tomato data set, mango data set. This is the data I am providing you, which is used for training and testing. So images are resized to 700 by 600 pixels during pre-processing before input into this particular model, which we named it as agriculture small is agri leaf net model. Basically, it's a one net model. We can call it as agri leaf net model. Analysis, after doing an analysis, conclusion is 700 by 600 pixel is the optimal size for pre-processing. And since we are reducing larger images to this size, so it is very efficient to use these smaller sizes than the larger sizes. Because the deep learning models train more quickly on smaller pictures in real time. Now here, different classes of potato leaf diseases are shown here, including healthy leaves, and those infected by early blight, light blight, early blight, and light blight. So this is the healthier one, and these are infected by and infections. Diseases considered are potato, early blight, and late blight. Here we can easily observe the differences between the healthy and the unhealthy. You can easily visualize. The same case here is for tomato. So under the tomato, we are having number of diseases observed. So very tough case, it's basically because tomato bacterial spots, tomato early blight spots. This is the healthy leaves. Tomato late blight spots. Tomato leaf mold. Here you can observe many categories of the diseases. Why? Compared to potato. So in case of potato, we will be having only, you can say, mainly two infected diseases are observed here. But in case of potato, in case of tomato, so many. Very simple, na? Because the life of the tomato, we can say in terms of the life, initially when it is available, it is in the harder form, and the age of that tomato is very less. Within a very few days, we can easily observe he, his life is converted from younger age to older age within few days, right? Means what? Environment affects the tomato very severely compared to potato. And in tomato, environment means pesticides and everything along with the your environmental parameters. It affects very severely. That's why we are having a fungal and all diseases which I explained with you, and their severe effects on the tomato leaves. That's why the detection process will be very complicated, very dangerous in case of your tomato. So guys, focus on this. I will suggest you to very simple again. First of all, very simple but very effective algorithms. Focus on these two algorithms. Focus on these two algorithms. These two algorithms will be very helpful to you if you are doing your research work at PG level or PhD level, or your area of interest is your design and development of the networks for detection process especially. Okay, so focus on this. If you are having a questions, definitely I will tackle those questions at the end, guys. Don't worry. But focus on the learning first. So here the first data pre-processing is done with the concept of access green index. So EXG in short, this is here. Hello, Praveen sir. How much time I can take? Manfred sir.
Yes, sir.
How much time I can take?
About 30 minutes, sir.
30 minutes I can take, na? Okay. So I will take more 30 minutes. So because accordingly I need to finish my presentation. So
Sir,
focus on
Sir.
yes.
Actually, we have a next session is scheduled at 5 o'clock. So I think 10 to 15 minutes are remaining. 15
Okay,
minutes.
so I will focus on now mainly on your algos. Okay, within 15 minutes I will try to summarize my work.
Yes.
Okay.
Yes.
So first one is your data pre-processing. So here the first algo I'm going to use is your access green index. Basically, what it is a vegetation index, which is predominantly used in remote sensing, agriculture monitoring, and environmental studies. For what purpose? To enhance the visibility and detection of green vegetation in RGB. Guys, simple logic. If you are having any leaf, and if we could increase its green effect, then obviously it will help us in proper detection. Okay, and EXG is the concept. With that, we can do it very nicely and in a very simple way, and at a very, in no time also. Okay, so it implies what? Because it implies the unique reflectance characteristics of the green plant to spotlight the green portion of the image. And how we are doing it? By simple formulation, EXG equal to 2 into G minus R minus B. We are having RGB image. So R and where B represents the red and blue color channels respectively, and G represents the green. So just twice the G value. So just twice the G value, definitely uh, your green effect will increase in every ellipse. So this is the complete, try to understand this one, algo one. Complete algo I have provided you for EXG, very simple. Take the input image, load the RGB image, and we will be having, as a result, RGB image ready for the process, first very initial step. Second, do the channel separation there. So separate the image into the three channels, red, green, and blue. So we will be having now what? Separation of the R, G, and B values over here. Next, do the or compute the access green index here. That is, compute this EXG value. So how it must be 2G minus R minus B. That is, we are applying here the XG formula to enhance the green channel and suppress the red and blue channel, so that we can easily do the easily do the detection. If normalization is required, then do it. Otherwise, it's optional. It totally depends upon your the size required. If the image available is within your limits, it's okay. Otherwise, do the normalization. And here normalization required here in this is between 0 to 255 values. Again, visualization. If you want, go with it. Otherwise, it will be again optional. And if it is proper visualization is there after doing a miss, if required, means what? After doing a EXG, if your image is properly visible, the data is properly accessible, then no need to do. Otherwise, do it, because if unnecessarily we are doing, we are adding a time to our process. We have to bother about it. Once we are satisfied with the final outcome of the EXG, we have to save the data. We have to display that data for further processing. And this way, we are having a output image, which is the final process image with enhanced green vegetation. This we want, guys, at the very first step. And because of this, we will be able to get more and more accurate outcome of the whole system at the end, we will see. So this is the first concept we will use. Now, in short, I have to cover. So here, so this is the visualization after the algorithm. So potato early blight. You can see here, guys, these infected areas are widely visualized. Can be easily blindly even say, I mean, you can visualize it very nicely compared to the original value. Because of 2G nature, we can easily observe it. So under the both diseases. So this is the outcome of the algo first. The same thing in the other tomato case also. Now, actually, I wanted to explain you everything in detail, but time limits. Okay. Anyway, come to the next regarding the model architecture. So, guys, what I shared with you, we are to nowadays think about the hybrid model if you want more and more accuracy compared to basic CNN designs. Okay. So here I am sharing with you is the hybrid model, which is nested mobile model, which is we have to use along with two-shot learning technique. What is that? I will share with you. So it is used for its feature extraction capabilities combined with a prototypical network for robust classification, mainly in cases with only limited labeled data. So if this is the limitation, if limited labeled data is there, for then and then we can go with the hybrid structure. But if it is a very, very unlimited labeled data, no alternate solution other than CNN structures. Okay. So once it has been done, then we have to do the pre-processing. We have to use the bilinear interpolation method. You are knowing the interpolation method to bring the normally it has been done to bring the data in the required formats. 224 into 224 pixel size is the required data. So here directly I will tell you the algorithm now. Come to the algorithm here. Details, try to understand that. Here total 8 steps are shown over here. Initial step, data preparation. So load the image data set, pre-process by resizing to 224 by 22 pixels and normalize the pixel values. Split the data set into training and testing sets. This is the general procedure. Then again here, added one is further divide input and query sets for few short learning. So few shot learning is a concept or the algorithm, you can say, which needs the data in the form of your support and query sets. So this we are doing additionally here, which is not being done in your CNN based normal structures. Understood? So in the hybrid case, we have to do this extra work under the data preparation. Okay. So output what will be the pre-proposed support and query sets for training and testing. So we are having now here, see the difference in the data output. In the previous case, experimentation one and here two. So here what we are having? We are having a data in the form of sets now, query sets and training sets. First point. Second is this is main job here. Okay. Second is now define feature extractor. Means you define your architecture now. So here we have to initialize this mobile architecture and we have to modify it by removing its final classification layer to use it as a feature extractor. Guys, understand? We have to use this as a feature extractor. Okay. So for this, we have to do the proper initialization of this architecture. How? We have to remove its final classification layer. Okay. To use it as a feature extractor. So this is basically input was what? The pre-processed image here, which was available in the set forms, query sets and training set form over here. And from this the input, we have to define the feature extractor here. So for this, we have to remove its final classification layer. And that way you have to generate the output that is featured vectors. So feature vectors extracted by your hybrid structure. So this will be the data now available at the step 2. Now, third level is the dimensionally reduction. You have to reduce the dimension of this feature vector because you have to reduce the size, you can say, the unnecessary data you have to reduce, you can say, or even the required data also we have to reduce here. How? By passing the feature vectors through a fully connected layer to reduce the dimensionality from 1056 to 256. So 1056 is the original size. You have to reduce it to the 256 dimension. Okay. So basically, under this third level, or third step of design of this algorithm, we are generating the feature vectors with reduced dimensionality compared to second one. Fourth one is the prototypical network initialization. So here input is what? This feature vector of support images and class labels. Okay, with the reduced dimensionality. This is the available data. So what we have to do under this prototypical level, network level, we have to compute the prototype vectors for each class by averaging the feature vectors of the support examples. We have to compute the prototype vectors for each class. How? By averaging the feature vectors of the support. We have to average what? The feature vectors of the support one. Understood? So here what we are having the support values. We are having the query sets values also. So support values data is available here in the dimensionality form, reduced form. So we have to do the averaging the feature vectors of those support values. Okay. So what we are having because of this, we are having a prototype vectors now. Previously, we will be having a feature vectors with reduced dimension. Before do that, we are having a feature vectors with maximum dimensions. Try to understand. Before do that, what is the output available? We will be having the data in the form of query sets and training sets. So and try to understand the output levels after every step. I hope that you might be getting this. Now, next one is the distance calculation. So distance between carry feature vectors and class prototypes is very important. It plays a vital role in accuracy or in because the loss and everything totally depends upon this one. So for that, we have to the data is now what? Query feature vector and class prototype, this one here. And what we have to do here? We have to calculate the Euclidean distance between the carry feature vectors and the class prototypes. So this distance we have to calculate here, and the final result will be what? Distances between the carry feature vectors and class prototypes. This will be the data available in terms of the distance now. So now next we have to do the classification. For what purpose? Purpose is to get the predicted classes for query examples. What is the predicted class we want? So then output we want. For this we have to do this classification stage. The input available will be distance between query feature vectors and class prototypes. So we have to classify query example based on the nearest prototype. Then training, no, we have to apply. Yes, we will. I will just conclude now. Training loop and then evaluate loop. So we have to do the lot of evaluation, and we have to measure the losses, training and testing losses under this level, and we have to then come up with the accuracy. So guys, lot of work I wanted to present, but time is not provided. So just see the detailed setup for your this National mobile hybrid structure. Here is the first part, the first step which I explained to you in the both the algorithms. See, my presentation was actually what I wanted to tell you is I wanted to provide you the basic structures, then the knowledge of the hybrid structures, both. Because teachers need the basic, not the detailing of everything. The student needs it. So if you are getting these basic ideas from this presentation, it will help you in developing your designs by your own. But I try to explain you the algos also. Okay, so whatever I explained you in the algorithmic form, that can be done in this particular in this particular processes. Okay, so these were the two things I wanted to share with you. The results are shown over here again, not possible to discuss. Here your performance parameters in terms of F1 score, recall, accuracy has been generated. Here you can see F1 score is highest here, 98, here 97 and 98% accuracy, which is again, you can improve, you can make it 100% also guys. 100% accuracy is possible with this hybrid structure, which totally depends on training and validation. So here you can see the plotting of the results here in terms of training and your loss and validation. Loss are plotted here, which are nearly, you can say, very closer to each other. It means the loss is very less. And if the loss is less, then obviously accuracy will be the maximum one. The confusion matrix data is also plotted here. You can see here the accuracy comparison of deep learning models for agriculture decisions using the hybrid structures. These are the different shown here. My presentation, what I discussed with you, especially the algos. For this one, I shown you. For mango, it is nearly 99.80%. Okay, so for potato, it is 100%. For tomato, it is 92. In tomato, in tomato case, everything is always you will get accuracy very less compared to potato and others. Because I told you already the result, technical reason also. Third setup was the basic student related setup, which you must take. Just brief, I am showing you. Lab setup, you can use this one. So these are the various steps you can handle. You can use the TensorFlow and its libraries for importing the libraries. Process complete is shown in the previous slide. Loading the data, labeling the data, transfer learning using then loading the data, label mapping, transfer learning, data pre-processing, building the model, uh, defining the loss function in the optimizer, then a training model, then checking the performances, then random tests, converting the model to the TensorFlow Lite model, then finally developing the model and generating the simple result on your mobile phone. That is the new, output, whether it is disease free or infected disease. So this is the laboratory based experimentation. So three total setups I briefly provided you. First one, broadly you can use. Second one, if the accuracy is highly important, obviously it is important, but the data will be limited one, not very high. Okay, and this is the student-based experimentation-based deep learning concept you can use. So many performance parameters you must focus on here: accuracy, map, recall, precision, F1 score, sensitivity, specificity. Summarize over here. What they are here. Presentation is with you. You can go through it. Then advantages of doing using deep learning in calculation in your agriculture. Conclusion of this advantage, challenges are also there, but they can be easily solved with the concept of the deep learning. Huge opportunities are there for this work in whole India, especially in the whole world also. by using this precision techniques and deep learning concepts. Conclusion is, guys, is the need of the hour. So we all should all it's a call to action basically to every individual one, to every farmer, to government, to one and all, because the country's economy, the country's happiness depends upon the farmers' happiness, and farmers will be happy if they will be generating uh, quality and quantity of the crops maximum. If the quality is very good and quantity is maximum, economy of the farmer will be happy and the country's economy will be again happy. And for that, definitely, we have to invest in AI-driven solution or deep learning-based solution for sustainable agriculture. With these words, I wanted to conclude, and this is the list of the references over here. Yes, guys, I'm ready to take your questions. Yes, hurry up, anyone. If you have any question, please, you can ask me the question.
Yeah.
See, the problem of your coordinator. Your coordinator has given me very minimum time. I mean, everyone knows. Everyone knows. Whenever I'm presenting, I'm not bothering about the time. And
Yes, sir.
my intention is to provide the best to my audiences.
Yes,
So,
sir.
is the problem of your coordinator? If you are related questions, if you are having to the presentation, fast, speed, limited, whatever, answer will be given by uh, only your coordinator. Related to concept, anyone, any concept, guys, you are most welcome.
Yeah, dear participants, I have given you, so you can unmute yourself.
You go to the, just I can tell you one thing. You go to the all matter which is given to you, okay, and try to understand the matter. Matter is enough for you to understand the concept. Okay, do first thing. Then, if you are not getting anything related to the concept, if because not possible to provide the detailing of each and every concept. The basic understanding by before presentation is what you are well, you all are having the concepts of image processing and the basics of the your neural networks. If you do have these two things with you, and definitely you might have gone through the image processing and computer networks or neural networks at your PG and research level, or you might be teaching also. So if you are having these two now, and if you seriously go through each and every slide, guys, I can assure you, you will definitely will be able to do the maximum work by your own. As and when you need any help, I'm always there. You can get the my email ID and the details from my from your coordinator. And yes, if you are having any question, you can please ask me.
Dear participants, I have given a right to you so that you can unmute yourself. Some of the participants have raised their hands. Ms. Pradnya Kambadi, Village Postal. Do you have any questions?
Yes.
Or
Yes,
you
please
can,
ask me the question.
yeah, or you can put the questions in the chat box. Okay, sir, I think there are no questions from the participants because you have given a very comprehensive presentation, which may help the participants. So I'll try to share your presentation with the participants if you permit later on, so that they can go through it again.
Yes, surely, I will send you my presentation. We can share with them.
Okay.
Okay, no problem at all.
Hello, sir.
Yes, yes.
Hello, thank you very much, sir, for accepting our invitation and given very wonderful session for us to enhance our knowledge. As always, you are our mentor. You are giving insights for every time. So likewise, today's wonderful session is also the insight for every participants. Thank you very much, sir, from bottom of my heart.
Thank you, Buyar sir. I am
Yes,
always
sir.
there
Thank
for
you.
you guys. I am always there. So as
Yes, thank
uh,
Yes, sir. Thank you from our management side, also from AICTE, and this given the opportunity for us to make one platform to provide one for our all technocrats to develop some of the applications for the society and the engineering enhancement. Thank you, sir. Thank you.
Thank you, one and all, especially the listeners, those who listen very patiently to me. And thanks to all the faculty, the coordinator, the vice principal, Dr. Bhuyar sir, and the management of your college. Thank you, everyone. Thank you.
So thank you, sir. Now we'll move ahead with the next session. So we have next session is by a person from the John Deere, that is Mr. Sandeep Rajput. He is going to deliver a talk on technologies in agriculture mechanization. Sandeep sir, are you there?
Hello, good evening. Yes,
Yes, sir.
I'm there. Yeah.
Yeah. Will you please try to share your presentation? I have given you the right as a co-host.
Okay.
Yeah, it's visible. Sir, you're on mute. Sir, you're on mute.
Entire screen. Hello, now it's okay, sir?
Yeah, it's okay, sir. Yeah.
Okay, okay.
Sir,
Yeah.
just want to know,
Ha.
in your presentation, your transcript is actually on.
Okay. So, do we have any option over here to disable it?
While sharing, while you are sharing, subtitle setting is there.
Okay.
So that is use the headphone and microphone. That option is there. You can start.
Okay. But is there anything about the
No, sir, no, it is not actually entering your presentation. You can go ahead with it.
okay, no problem. Maybe I can yeah, I can start with that. And yeah, not sure where the option is over here. Keep slide updated and show. Fine. Okay. Okay. So good evening, one and all over here.
Sir, shall I introduce you? Or you continue?
Okay, no problem.
Yeah. So, good evening all. Now we are moving ahead with the last session of this our faculty development program, and our today's topic is on new technologies in agriculture mechanization, and our today's expert is Mr. Sandeep Rajput. He is a team lead in John Deere, Pune. Basically, he is a well-known mentor in the T-Fund for the different student projects at different colleges. So he is has a vast experience in agriculture mechanization and using a different cutting edge technology for the agriculture practices. So I request Sandeep sir to start with his presentation. Sir, please.
Yeah, thank you, Mr. Wankade sir, about the introduction. Yeah, so almost with the 15, 16 years, I'm into the field of agriculture innovation, wherein work with the many advanced technology projects in terms of automations and even in mechanical developments for the agricultural products. So John Deere is one of the well-known organization which is basically known for the technology, and we are doing a lot of efforts how we can go elevated in terms of agriculture technology as an organization and how that can be benefited to our farmers. So that's one of the important aim. So in today's session, mostly I would like to go through some of the technologies, what how John Deere is supporting in terms of agriculture mechanization, and what are the second intent is how these technologies can be leveraged to India, because most of the things are global technologies, and what kind of scope we have as a faculty or as a academia or as a industry, what kind of scope we have in terms of startups or development, so we can get few of the insights from that. That's one of the objective, and few of the things we can look over the what are the scope in terms of mechanization in our agriculture domain, considering our Indian duty cycle. So what challenges and all. And third, maybe I can also talk on little bit on the what are the something on the precision ag and smart farming. Maybe this topic might be covered earlier, but maybe I'll just quickly go into that and just give you glimpses on that front as well. And if the time permits, maybe I would like to talk on the e-mobility in the agricultural, right? So that's the coming up area, and where we can learn at least what things available with us and what are the challenges, right? Into if you want to go with the e-mobility. So that's the plan. Maybe I will start with the little bit on the or India global on the labor force side. So if you look to the GDP contribution in overall, so basically industries consist of IT or agriculture or any kind of domain. Those are like 20%, 26% contributor as a economy, and the services are almost 57%. Agriculture is 17%. So we generally used to call as India is the agricultural organization or country, and still our GDPs are 17%. That's it would be says less, but still it's good, I would say, because in other countries like if you say the Europe or America or maybe other continents also, the 17% we are good in terms of the compared with the others. That's the one thing. Second thing is on the labor force. If you look in detail, so we have again these three more elaborated kind of or more composite kind of structure, where the industry is using 25% of labor to get the 26% of GDP. That's fair enough, I would say. But services are very good. Like they are like using 30% of labors to get the 57% of GDP contribution. I think that's one of the good area, right? So services are they are on the right path. But if you look at the agricultural, so to get the 17% of GDP, we are investing almost 45% of agricultural labor, and that's something as a very bad feeling, right? So we are using a lot of labor force, and that's how the need of mechanization is there. So how this 45% can be reduced to like 17, 80%, so that we can add par it with our GDP growth. So that's the important thing we all need to understand first. And why the mechanization is important, the reason behind is like the we are using larger labor force to get the less GDP, and that's the reason this gap we want to breach and minimize. So how to minimize this gap, and there are a lot of solutions, technologies, and avenues are there, but it may not be the case like everything will be suitable for us, right? We need to find a right way or approach, considering our current situations, and even there are a lot of challenges with our current situation also, right? We have cost infrastructure, right? There are many I would say challenges and unfavorable environments. So we need to study into that and take a right choice or decision how we can which mechanization we should choose it, and what are decisions available with us. So, if you look at the agri mechanization a little bit on the global side again, so maybe the first graph I would like to highlight here is so if you see if you talk on the globe side, like the mechanization percent of 95, maybe those will in the little bit on the higher dark green side, right? if we talk on this area, it's like 95%. But once we go in other areas, like so we have many countries which has more than 60, 70, 80%. But if we talk about India, it's like 45%. And that's how, if we compare ourselves with the other global, then we are far far behind. And even though we have resources, we are good in terms of natural things, but still the technology is something, or mechanization is something that we need to increase, so that we can at least increase this number from 45 to at least close to 70 or 80. So if you talk on how this 45 is really segregated, or how this 45 is really distributed. So one of the important thing is like, if we consider the agriculture as a complete system, I'm sorry, this complete system is divided into the four different categories or areas, we can say. One is the land preparation, second is planting, transplanting, third is the crop care, and fourth is the harvesting. So if you look the percentage of mechanization we have as on today, so land preparation, I would say we are good into this area, since we have 70% of mechanization already available. So in land preparation, if you go in deep, so what is the things we have? We have many tillage equipments, we have many tractors, right? We have autonomous tractors also available. So many of the tasks, many of the functions, I would say, those are already available, and many of the tasks are get automated with these machines, and that's the reason we are at 70%. So I would say if you have 100 tasks, so 70% of tasks we are doing with this some automation, and that's the reason we are at 70%. But still there are 30% we need to improve on that. And I think there are a lot of things are coming up to bridge the gap of 30% also. But the worst thing is, or what do you think is, if you look at the planting or transplanting, right, that's the one area where we are at 38%. Now I would say that's a real challenge. If we go into the south zone, where the most of the areas or land is irrigated with or planted with the rice, and we all know, right, how rice is get planted today, right? So it's a very hard process. So labor has to go into the water, and there are a lot of challenges. There is mud, and so it's all the things are done by the human, right? So it's highly impossible, like it requires, right, lot of human efforts, and there might be some kind of efficiency reduction into that, some kind of I would say the it's kind of tedious job, I would say, right? So so how we can help them, right? How we can automate this process, that's the important thing. But as of now, if you look as India as a country, so we're at 38%. So I would say there is a long story or long way to go into the transplanting or planting, if you want to raise the bar from 38% to the 70 or 85%. Similarly, if you look at the crop care area, so crop care is like taking care of the crop, right? So we are already planting is that, and then we have the crop available. So how we can nurture that crop? By helping of giving the technological solutions, right, in terms of controlling the weed, in terms of spraying, in terms of there are a lot of operations, providing the fertilizers, providing the watering. So what are the care as on today we are taking for the crop, those are under the crop care. So right now we are at 31%, and that's again a very worried news for us. Ki though we are a developing organization, developing country, but these are few things where our farmers are still looking for good and nimble solutions, right? And where we are actually lagging to provide that solutions to them. So most of the things still we are doing with the manual operations or with some semi-automatic operations. So this is the sector or area where we need to put a lot of efforts. We want to really understand the pain points. We sometimes we know the pain points, but the challenge is we are not able to provide that kind of nimble solution to the farmers, and that's the reason this graph is not growing up. So reason, there are many reasons, like we discussed, like we talk on the cost, we talk on the situation, we talk on the infrastructure, right? So this will be always there, but because of that this level of mechanization is not growing, and that's how we need to go in deep and understand how we can mitigate these challenges, so that we will move from 31% to even 50 or 56%. Good thing is like that now drone is coming up, so which is always providing a good I would say the aerial solutions in terms of spraying and fertilizing and all these things. So that's somehow reducing or increasing the efficiency of again resources reduction. But apart from drone, what extra or what other things we can do, that the real area of thinking or area of looking into that. Similarly, if you look at the harvesting, so now we have the land irrigated, we have the crop developed. Now the last part of getting the yield is the harvesting, right? So harvesting is the one area where again most of the operations that we are doing manually, right from cutting, threshing. We have some semi-automatic machines. So now the harvesters are coming up, but still because of some challenges of less land holding of farmers, we are not provide the complete economy or complete economical solutions as a complete package for the harvester to the farmers. So there is a big opportunity or there is big need how we can consider this small roads, small farms, and taking that into account, how we can develop the kind of machines which is with the variable tread with kind of machines, right? Or machines with the variable wheelbase kind of machines, right? So those can be changed based on the needs, based on the roads condition, based on the farm condition. There are many factors. We should have the machines with the smaller turning radius, right? So that will be surely helping in increasing efficiency. So those things we need to go in deep and understand the actual pain point. So broad level we know, right? Broad level everyone is talking ki in India there is less land holding, but what we can do to overcome the less land holding, that is important. And that's the reason we can go in deep and we will understand what is the best solution available for the Indian market, so that we can move our graph from 32% to the higher level. So I would say you might have got the fair idea, like where are the opportunities and where we can put our step ahead, so that we can provide the right solutions or right approach to the farmers. So to be honest, we have I'm not sure what is, yeah. So we have mostly the transplanting, crop care, and harvesting. These three areas still that we need to grow more, and land preparation we are in the good phase. So these challenges we know, right? But still, if you go into the global view or higher vision level, so we have the, like the access to the advisory services and agriculture information. So there are many Kisan agro sectors or offices are there, but the right information not reaching to the end user. That's one of the challenge, and there might be reasons behind that, right? Not every farmer is using the internet things. Not every farmer is really willing to go into that offices and understand what thing is needed based on his field requirement. So I think more awareness is required in this area, so that what our agriculture sectors are doing, right? There are ISE, there I would say ICAR is there. So there are many organizations. They are doing a lot of great works. We also seen in past sessions there are many development is going on, but how this information can be really leveraged to the end user, that's important. And that's the reason this ICTs, or I would say the agriculture sector, has to come up with some new methodology, so that they can provide the information in deep and it can percolate to the at the ground level. And that's also part of agriculture marketing, where we are now is a area of maybe era of digital marketing, right? So how the digital marketing can be leveraged to provide the agriculture information, so that each farmer will be more aware, right? So by using some mobile news or by using the some media and all these things, so he'll be really aware about these are the technology available, how not as 100%, but how we can utilize at least 10 or 20% of that. Even if you utilize 10 or 20% of that, then also it's create a big impact, I would say. So we might have seen many things are going in horticulture area also, right? Many farmers are coming up with new technologies. They are working with the some kind of different kind of foods, organic farmers and all. And there are many success stories into that. And that's and we have that success stories. The only thing is how we can uh, elaborate and how we can percolate that success stories into the other word. That's important. The field problems, right? We have the pesticides, soil fertilizers, water irrigation. So these problems are always there. So but it creates a challenges for the development, basically. Food safety, quality. So that's again we have different standards, right? We have FCCI, we have the different standards by the SE also, different standard by the Indian government also, central government is also, right? But how collaboratively or how authentically those products can be adhered to the standard, that's also question mark. If it is happening by that way, then it's again a good development, or one of the way of good development, I would say. the farmer welfare is subsidized in agriculture insurance. So I think in many things government is supporting, right? In the crop insurance side, there are many subsidies if you go for the new kind of technologies in terms of irrigation. Now solar is coming up. So I think there are a lot of initiatives are going on, and I think these initiatives, but the challenge is not everybody is aware about that initiatives and how those can be implemented to larger area. That also again we need to see. So again, the third or important point is the low income business venture. So we all know, right? So it's a kind of tendency, right? Agriculture is not a high income zone, but and that's true also because of considering the high input cost and lower yield cost, and there are a lot of challenges in terms of the labor scarcity. Again, we are dependent on the natural resources. So that's the mindset basically, but that's our duty how we can change that mindset. It's kind of low income zone to high income zone, right? So there are, that's why we are saying the adoption of technologies. So mostly the farmers are a little bit reluctant or afraid about the new technologies, right? So everybody is worried, what happened if we brought this, what happened if we use this, right? Unless we have good success stories or good area of examples, then and then only farmer can be convinced to use that kind of thoughts and that kind of technology. So that's something we need to look into that and create that kind of literatures or maybe the success stories, so that everybody will be in position to accept these technologies. So the rate of adoption of technologies has to be increased, and without that it's very impossible or very hardly possible to mitigate the challenges for the mechanization. So if you look towards the in fact the population level, right, or by 2050, I would say it's like a 10 millions, right? So but are we enough capable to provide the food by that time? That's the question, right? So now also we are in the situation, sometimes there are a lot of drought situation, we are completely dependent on the climate, right? And obviously the whatever the natural resources we have, those are under stress conditions, it has also certain limits, right? So we really want to understand like how we can reduce the dependency on the natural resources, and should we try for that is sustainable kind of modeling, right? That something is coming up if you want to reduce the dependency on the natural resources. So we have to think or thought or maybe enrich into that level so that there is a less dependency on that, so can we can continue our journey even though population is growing. So we need to balance that thing, that's important. Again, deforestation and all these things are again the one of the depreciating factors basically to pull down the agriculture mechanization, right? So we need to really look into that, how we can reduce that thing. The land quality again, right, because of using the traditional way of doing the farming, the obviously land quality is again degrading. We cannot take the multiple I would say the higher revenues with the same land. So there are a lot of practices, and again it's on depend on ki how we are learning the things, how we can understand the soil technologies better way, and what kind of how we can so for that there are many things, maybe we can look into the further slides, what are the ways to understand and mitigate these challenges again. So team, here is agriculture 4.0, like we might have heard about the industry 4.0, right? So similarly like agriculture 4.0 is also there. So part of maybe basic pillar of that is precision agriculture, right? The many speaker might have talked about this precision agriculture, and I think I'm assuming that you are also good aware about these technologies, right? What we are doing in precision agriculture, right? So that's one of the important pillar for the agriculture 4.0. Smart agro industry. Again, we talk about the resources, right? How we can optimize the resources in a proper or optimized way. That's the one of the pillar. Digital agro logistics system, again reduce the inefficiencies in agriculture value chain. So these inefficiencies can be into vertical domains, right? There are different domains. It can be from the different sectors, right? It can be from the different areas. It can be from the labor operation. It can be from the automation. It can be from the using the pesticides. It can be from the different kind of operation we are doing while developing the agriculture, basically. So this inefficiency in all the domains. So we need to understand how we can be more efficient by using the new technologies. That's the one of the way. Smart e-commerce system. Now the again there are different web platform available, right? We have data and AI coming up. So how again we can utilize that, and that's also part of agriculture 4.0. We also need to understand ki why there is need of 4.0, right? So again, it's again a, I would say, controversy of what is the need again, right? So it's like to have more productivity, right? We know we have capacity, we have potential to do it, right? But how this potential can be enhanced, right? How this capacity can be enhanced, and that's how this 4.0 states about, by using some of the pillars, these of the pillars. If you use this pillar in different areas, then obviously this 4.0 will be get enhanced, right? Then the, if you look on terms of the advantages, obviously it's a more often like getting the higher return of income, right? Now if you are talking about the actual scenario, if the farmer invests 100 rupees, at least he should expect around 30 to 40% profit out of it, right? But sometimes this ROI is in negative. So how we can have the more and more ROIs, right? If you're putting the amount into the field, how we can get the higher amount? That's how the ROI numbers that has to be increased. And without technology, without adoption of the new things, it's not possible, right? And that's the reason the agriculture 4.0 talking about these pillars, and they are creating the needs to utilize into the today's world. Again, we talk about the networking, right? So we have still there are a lot of opportunities we need to grow. Like we have the development centers. I think there are a lot of exhibitions are going on. We have the Kisan Mela plan on December. So these things are there. Again, this kind of events or exhibitions are giving a lot of value to understand the farmers, how, what are the different avenues available for them, right? There are many semi automatic machines are coming up, right? So this is the good way of, again, I would say, one step ahead, how the energy can be transferred into the awareness, so that the maybe the, and one of the importance again, to develop more and more startup, right? To go into this area and develop the more and more cost effective product for our farmers. Again, the sustainability or environment friendly is always a point of discussion, and one of the aim of agriculture 4.0 is to look into that, how we can reduce the dependencies and going for the lesser waste and increasing the more sustainable solution for the farmers. Because if this thing is sustainable, then obviously it will impact less on the environment hazards, and again, it's a, I would say, correlated to each other. So it's a kind of direct shift if we look towards the actual thing now. So right now we have something we are doing, and how it can be directly shifted, right? So traditional farming is completely shifted with the smart farming. So we also look into some few things on the smart farming, how the smart farming is doing, get accredited. Then the second thing is traditional, I would say, the engineering companies and organization, right? Those are converting into the entrepreneurships and maybe small startups, right? Again, service sale. What is this? What we are efforts we are doing in the traditional services is again going for the high value services. So it's about putting the same effort but getting the higher yield, higher gain. So using the less input, how we can get the higher output? That's how the shift is happening. And the reason behind of this shift is agriculture 4.0. How it is, why it is. So lot of different technologies are backbone of behind that. Lot of different practices are there. There are a lot of things are helping into that. If you talk about the labors, right? So earlier there are a lot of gap, right? Though there are no machines, mostly usual things is done with the very few limited information. But now there are a lot of depositories available. There are many research institutes are there. They are working day in day out to create a simplest solution, right? And how the one of the I would say the pillar for that is the getting the skilled knowledgeable persons to operate that machines or to operate that technology. So that shift has to be happen, and this shift is happening because of the agriculture 4.0, and that is one of the important pillar. So to create this new journey, again the shift is happening from buy technologies to make technologies, right? So most of the things we are totally depends on the US and Europe earlier, right? So even though many germination seeds and many I would say the technologies in combines, technologies in crop cares machines, we are still dependent on that, but the ratio of dependency is getting reduces now because of the Atma Bharat initiatives, and even the initiatives like the Make in India. This many of the technologies we are building our own, and that's how the shift is happening. So there are a lot of things are happening and a lot of things are going on. So obviously, if you think or consider the model of Sri Lanka e-agriculture strategy, I'm not sure how many of you know about that, but the Sri Lanka is managing the complete infrastructure in a very great way, right? They have very systematic process and strategy to develop the agriculture. So if you go, you can search into the even the medias and even there are many literatures also. You can go in deep and understand how the Sri Lanka e-agriculture strategies are there, and can we get something out of it to increase our Indian economy or Indian pharmaceutical practices. Yeah, I think this was related to agriculture 4.0. Why this needed and what are the pillars? Maybe I will take the e-mobilities part later. Quickly, I will jump to first into the uh, smart farming in 10 minutes, 10 15 minutes. And then we'll move to the e-mobility in the agriculture, and then maybe we look for the what technologies basically John Deere is helping to support the farmers. So precision farming again, it's a very important, right? If you look at the aspect, right, if you talk from the what is that and how it is required, basically it's about the improving the crop yields, right, reduce the resources, and how we can increase again sustainability, right? So these are the main three pillars. Challenges, we are looking at the population, again climate change and natural resources. Again we are depending on these three, and that's the reason we are these are the three things we need to mitigate the gap, and that's how the data driven approaches are helping us. So it's all about the getting the data. So we are doing this farming almost maybe more than 100 150 years, right? So we have a large amount of data, we have various data, we are using different multiple crops, we are using different machines, we are different using different pesticides, we are using different herbicides, we are using different weed controls, we are using different tillage equipment. So we are different practices we have, but what we did is we don't have the data. So the first thing is we need to collect the data, and actually to be honest, we don't have to go in deep. We have already data collector, we have the many institute those having this data, and by studying this data there are certain kind of I would say the decisions has been taken place. So again, but if you want to look case to case basis, then if you see the last practices what we followed, we can really find out. If we go with the maybe the depth of control in terms of tillage, if you go with the kind of nutritions required for our land, if you go with the kind of moisture level which is required for our land, so these are the inputs, right? If you understand this input in a better way, for sure we can control our yield in proper way. And that's how this precision farming is coming up in picture. So what this talk about, you collect the data, whatever practices you're following, you take a note how many proportions, what kind of proportions you are using while maybe fertilizing, what kind of what frequency of irrigating you're doing for your field, what frequency of level of moisture content you have, what kind of soil you have. You can test that soil, right? You can understand the nutrient level of your soil, and based on that data you can really understand if I do some sensitivity analysis, right? If I go for the higher nutrient, if I go for the less kind of potassium, less kind of nitrogen, so this kind of decisions we can take. Now, if I reduce the frequency of watering, or we can reduce the frequency of weed control units, so this kind of decisions we can take through the data, and that's how precision agricultures are in place. So there are many machines, right, available to utilize these technologies in India. It is coming up. So there are some startups which is working for the precision farming, but there is a long way to go. Again, uh, so what are the different aids or tools are available over there? So to get this data, we have the GPS, we have the GIS system. Basically those talk about the how our fields are there. So GIS system is really helping us to understand our field nature. So which is the area where we have the high trades, which is the area where we have the soft kind of soil, which is the area where you have the hard kind of solid soil, which is the area where we have the brown kind of soil, which is the area where we have the black soil. So we really need to understand the pattern of soil. And my dear friend, please try to understand this pattern of soil is creating a lot of value to increase or reduce our yield. So we really want to understand what pattern is suitable for your yield, what pattern is suitable for our crop. So that's the reason the GI system is very much helping to us. Again, in India, the biggest challenge is the small land holding. So everybody is not capable to get this GIS system and GPS system, but there is opportunity. Maybe small startup can be developed, and where the GIS or GPS system can be installed on the machines, and they can collect the data and they can provide some kind of solution to the farmers. Hey man, this is the area where you can, this is good for the sugar cane, this is the area, this is good for the cotton, right? So this kind of suggestions or decisions can be taken. Again, remote sensing, that surely help talk about the health of your crop, right? So we can understand, so everybody, there's brown on green or green on green. So that's the thing, scenario is there. But out of that also, which is the area or which is the kind of particular zone where we have the if you go with the less water content or maybe the higher moisture content, then our healthiness of crop can be increased, right? So this kind of information can be captured from the drones technology, right? Then there are different sensors available, right, to understand this again. So these sensors are, if you look at the high-end machines, maybe I have few videos and how this GIS, GPS, soil sensors can be used to understand the nature of soil and to understand the nature of different ingredients of farms, so that the decision can be taken properly, right? So there are different crop health sensors also there. VRT is the variable rate technology. Again, this is a very important topic, I would say. And VRT is mostly used for the in the planting as well as in the seeding or in the spraying. So this rate can be decided based on the what kind of spacing we are keeping in our land, what kind of planting space is available, what kind of requirements are there, how we can change the specification based on the needs. That's how VRT is used. And for to complete this VRTs, there are a lot of mechanisms are there, right? There are a lot of controls, I would say. So maybe we can look out more if time permits how VRT is useful. So we talk about some of the information centers, right? So these information centers is like they can take the few samples from the soil and they can really test different tests in laboratory, and they can generate a report, and that report can be shared with the farmers, so that farmer can be understand, okay, this year we go with the sugar cane, but now there is opportunity to go with the multiple crops in sugar cane. Also we went with the this kind of variety, but now we can change that variety, right? Because our report is saying that if you go with that variety, then yield will be more, right? So this kind of some kind of decisions, right from the starting of planting or even the seeding area, is really helping us to understand our yield and save the cost and resources as well, right? So we talk about the precision farming also, and now this is the one thing like autonomous and automated equipments, right? So obviously technologies cannot be driven with the autonomy. So autonomy is one of the killer, maybe the key pillar, I would say. And there are a lot of machines, right? If you talk about the tractors, so tractor is like, if you look into the US segment where we have the 2000 hectares of land or 4000 hectares of land, I mean 1 or 2 persons are managing their land. So how it is easy for them to manage the 4000 hectares of land by 1 or 2 person, right? Because there is no labor over there, and without labor managing that kind of operation is a kind of hectic, I would say impossible. But now technologies are going in a such a way that the autonomous tractors, they are judging all the way, they are doing all the operations very versatilely, very efficiently. There is no need of I would say the labor or no need of manual intervention itself. So this kind of level of technology is already there. Obviously cost is associated with that, but technologies are available. That's the point of discussion over here. Second thing, there are a lot of things are coming in planting also, right? So we know with the manual way there are a lot of tedious things we have to do it, but if you go with the technology, then there is some advantages over there, right? We are somehow we are doing the automatic, but we are also reducing the uh, risk of crop loss, I would say, right? Because it's a automatic operations and everything is set based on our farmer need, right? Even we can control the spacing, we can control the uh, maybe trade weeds, we can control the type of crops, everything can be managed by the autonomous thing, right? Then we can talk about the harvesting, right? We talk again these four different areas. So in every area there is a lot of technologies are there and a lot of innovations are going on. Again, intent is basically to go for higher yield, cost saving, sustainability, efficiency. Those are the main pillars. And I would say the sometimes it's very easy to maybe understand that, but data management and maybe connectivity, or in a short we can say the infrastructure, that's the one of the again challenging situation, right? We know the EV is coming up with a greater way, but because of infrastructure still, that's a dilemma in our mind, right? Whether my car will go for beyond 250 or not, because the Indian infrastructure is not so much capable or compatible to manage the things, right? Even we cannot think of even getting the EV into agriculture sector because of this infrastructure development, right? There are opportunities, but how to manage that thing is again a real challenge. So robotics again creating a very key role. So we said about the precision farming, it's again depend on the autonomy. Autonomy is depend on the robotics. So it's a chain. So robotics is the one of the, I would say, the important technology which is helping to go for autonomy or automation, right? So in robotics also there are many ways. If you see the now industry 4.0, industry 4.0, I would say that 30-40% depend on the robotics technology. Every line, every operation, every I would say instances is done by the robotics. It has a higher efficiencies, it has very I would say less losses. We can control all these things because of just because of robotics. Because of robotics we can even increase our scope of utilization, and that's how it's creating a important role, right? There are self-driving, I will say, lot of things we need to do. There is a programming is coming up, different codings we are doing, right? So a lot of set of practices are following up to make this happening. But again robotics also there are different technologies, there are different applications over there. There are certain kind of autonomous robots which is basically used in kind of a lot of industries are using it, a lot of in FMG sector they are using it, right? Harvesters are there, these are taking the help from robotics. Certain kind of robots are used for the weed controlling, right? So there are many things. So the robotics are really one of the key pillar to help the precision farming, I would say. And it has certain advantages again. There are different scope also there. So we can have the collaboration with the computer vision technology in the robotics, right? We can integrate different sensors, right? So with that, it's not about one system, it's about collaboration of different system into one, and that's how the smart farming is coming up, right? With the use of data, with the use of different cameras, with the use of different sensors, with the use of different interfaces, right? Again maybe the next topic, so we can talk on IoT also, right? So these are something about the case studies. Maybe I'll not get in deep, but IoT, yes. Team, maybe I will be going a little bit faster, a lot to cover, but let's talk a few minutes on the, or understand few minutes on the IoT, right? So simply we are saying the IoT about the Internet of Things, right? It creates a revolutionary journey in the farming practices. Everything is runs on IoT, right? So we learn about the robotics is mostly on the mechanical practices, right? So we can have the mechanical structure, but to run the robotics or to give the command, IoT is helping us. How the communication has been transferred from the direct implement to the farmer, that has to be done with the help of IoTs, right? So it's all depend on the more of a like communication. So IoT is really having the great infrastructure, I would say, importance into that area, and that's how it's helping in terms of crop management, right? So every information that can be get assessed through IoT, every information that can be captured through the vision technologies, every information that we are following, that everything can be done with the help of IoTs. So, if we look a little bit details, like what are different applications and all, again, smart irrigation system, where that is one of the important application. What IoT is creating a different value into that, crop monitoring. So again, it's intellected with the different sensors and technologies, but these are few applications where the IoTs are creating the value. Livestock management. So basically, we have different. It's very good examples. Maybe in India, it's not in much practicable, but if you look in the US or Europe, so livestock is the one of the different business practices. So what they do is like they're using different sensors on animals, and they will understand their complete system, how their digestion system is working, or what kind of food is suitable for them. There are a lot of studies are going on. There is one project I recently work on increasing the PLI index. So these cows are there. These cows are mostly, we can say, the cattle food. the cattle foods depend on the PLI index. So this how this PLI so what are different PLI indexes are there, and which is the best PLI index to increase the higher milk giving capacity of the cows. That's what that project related to. And there are a lot of parameters basically. If we change the content of even the spreading content of chopping of that particular cattle's food, so by using that different parameters we'll be getting the different PLI indexes. Even if we change the shaking rotation, or if we process that particular food in different temperatures, then also PLI indexes has been changing. So very vast topic, I would say, and IoT is helping to do that study. So IoT is really helping right from the getting like what size of cattle foods we have, what size of chopping we can do, what size of shaking RPM we can keep, what size level of temperature we can do it. So these parameters can be optimized with the help of IoT. So without just regular analytical calculations, it's very hard to do it, but IoT is giving the that value, so that we can understand the complete graph with the help of Power BIs, and understand the which parameters is prominent, which parameter is less prominent, and we can do that sensitivity or relation adjustment, so that our overall gain will be high. Again, the supply chain management is one of the important topics. So in terms of agriculture field, we have the different blockchains, right? We have different I would say economy things, but the logistics and supply chain is one of the area where IoTs are creating a roles, because there are different vendors, different stakeholders, and getting the information from these vendors to stakeholders and providing it's coming from farmer again. So it's a huge network, and communication between this network can be achieved through the IoT. So IoT is giving that kind of data-driven interface, and using that interface, we can, one click, we are able to understand what is the need of that vendor, what is the need of this company, what is the input is needed. So we can run this all this complete economy with the help of IoTs. So these are again some case studies, I think, in terms of blockchain technologies, in terms of developing smart farming ecosystem, again developing in terms of enhancement. So few things are there, few projects are there. Okay, so let's talk about the AI and data analytics, how these things in helping in agricultural, right? So we talk about the IoT, and again IoT is one of the subset of DI and maybe the analytics over here. So going in deep over here, maybe okay. So going in deep over here, so we talk about like different data. So data analytics depend on all the data. So how we are getting the data? We talk about different farmer practices, right? Right from the selecting of different kind of seeds. What kind of seed we are selecting? There are a lot of varieties, right? So that data is different. That is a set of data. Then what kind of spacing we are putting while putting that seed, that's a different set of data. What kind of crop width we are fixing during our planting, that's a different data set, right? Then after that, once the seeding is planting is then it's coming about the fertilizers, what kind of fertilizers we are using, what is the proportion of fertilizers what we are using. Then coming to nutrients, that what quality of soil we have, what are the nature of stress level of that soils or nutrient level of that soil, right? So this is again different data set. So all this data set can be studied, and with the help of that data set, we can put this or give this input to the system, and system will give a value for us or give a decision for us. This, if you keep the percentage of nitrogen, percentage of carbon, or percentage of potassium, 13%, 2%, 8%, whatever it based on that, and with this kind of maybe germination power of seed, there are different DOEs, design of experiments, the system is doing behind the screen, and that DOE is really kind of permutation combinations. It's a combination about like if you take a X type of seed, X type of irrigation moisture content, X type of soil, and X type of cropping methodology, then what is my output? So if you have the data, then it matches the which is the best combination, and which is the give the best combination and best practices basically. And if you follow that practices, then obviously our yield will be high. So again, there are a lot of challenges. We cannot use the complete system in today's world, because we are lagging in collecting the data. To collect the data again, we should have that kind of instruments, right? So companies have that instrument. They are talking to different farmers. But one thing we can do as a maybe as a faculty or as a academia or as a kind of one of the practitioners in agriculture mechanism, we can take a surveys. We can reach out to many farmers and understand what kind of crop practice they are follows, what kind of soil they have, and we can generate the data. And this can be one of the good project. If you have good amount of set of farming practices, and that data can be studied with different combination and permutations, and we can use the different codes like the web analytics are there, and we have also success stories, and from the success stories we can use some coding over there, some programming over there, and use that programming coding into our data. Then obviously the yield will be, or maybe the whatever suggestion we'll be getting, that will be the definitely higher, or maybe enhancing solutions. That's how we can do the using of this data and AI to use the right, take the right decision for our farming practices. This can be one of the good projects for the agriculture or universities also, because they have a lot of different types of crops, different types of practices they are following. They can really monitor and capture this data and do that analysis, right? And they can also find some of the crux from the success industry, success examples, and use that crux into the regular approaches. Okay, I think let's move to the, we have I think 30-40 minutes more, but let's talk on yeah. So we talk about the smart farming. So I just want to help you to understand how these harvesters and maybe different technologies into the available for the precision farmings, right? So we may have to go for quick videos. Again, this is for the internal consumption, but just want to share with you a few of the things. Let me know if sound is audible. Sound is there, sir? Yes, somebody confirm whether sound is coming.
Yes, sir, sound is not. Will you please
Sound.
play the video? There is no sound, sir.
No sound. Okay. I think during share I need to do some setting. Just hold for a minute. Here is that option is sound.
At John Deere, we've continued to push the boundaries so that we can
It's audible, sir.
offer growers as many profit-generating options. At John Deere, we've continued to push the boundaries so that we can offer growers as many profit-generating options as possible. But to get to that truly next level of performance, we took a giant leap to ensure that you get higher levels of yield and productivity. Let's take a closer look at what separates the game-changing ExactEmerge from other planter row units. As you can see, there's no seed tube. Know what else you don't see? Seed rolling in the trench. We replaced the seed tube with a new delivery cartridge, the heart of this revolutionary planter technology. Inside, you'll find the brush belt, which delivers seed directly into the trench on a dead drop, with no roll, at up to 10 miles per hour. Each seed is carried by the brush belt, but not before passing by our all-new seed sensor. Think of it as another set of eyes where you need them most. Population, singulation, spacing information, it's all gathered at the sensor. Every precious seed is carefully spaced and carefully placed. The new bowl-shaped disc singulates your seed, while the concave shape allows the brush to grab each one effortlessly. Watch how these paddles push seed into the center of the brush belt so you can feel confident knowing there's a secure handoff every time. And thanks to the improved brush style double eliminator, only one seed rests in each hole before the disc hands it over to the brush belt. This allows you to enjoy the highest possible singulation. Of course, this high-efficiency meter system wouldn't be complete without a superior vacuum. That ensures the disc holds the seed tightly before it's passed on. Check out the new hopper design that helps you get the most of your seed pool by maintaining target seed population on slopes of up to 15 degrees in any direction. But there's more. 2 independent electric motors keep AICTE running smoothly. One that rotates the meter, the other turns the brush belt. This gives you the speed matching delivery and population only AICTE can offer. Not enough? How about the fact we've made active pneumatic downforce standard on this planter? And when paired with the new brush belt delivery, you get optimal depth for maximum yield at 10 miles per hour. Just set the downforce margin you want and run confidently. It's that simple. Finally, a planter with no trade-off between speed and accuracy. A planter that buries the myth of only planting at 5 miles per hour. A planter that marries precise seed placement and productivity. It's the all-new AICTE row unit from John Deere. Accurate at 10 miles per hour. Exactly.
Sir, you are on mute.
I think, sir, what happening? Whenever I'm switching to video, na at that time. Now it's audible, right?
Sir, it is audible.
Yeah. Yes. So I was talking about the purpose of sharing that video with you. So we talk about the precision farming, right? So how these important parameters. It's not about the theory. It's about the how these parameters are really helping us to in our day and day out operations, right? So I just want to go with that slide once more. Right, so we talk about different sensors, right? So if in case of just planter is the one just simple machine, but if you look in detail, right, from the exact spacing of seed to be placed into the field, right, from the amount of depth has to be controlled which is required for the good germination of seed, right, from the angle, right, that has to be required so that the complete seed can be get covered after the seeds get placed. So these are very smaller things, very I would say minor things, but it creates a lot of value. And to understand that, that's how the different sensors are working, that right, you seen that the planters, it has a different wheels, right? That wheel is actually, it's not a simple wheels, it has a different mechanics involved into that, right? The angle of wheel is important, the material of wheel is important. So these parameters can be adjusted based on the need of farmers. And that's how this we talk about robotics, we talk about the data AI, right? So we also seen about there are some sensors which is actually giving the exact count of seeds. So see the important of that, right? The count of seed is giving the information to the farmers. Now he is well aware if he has a exact acre of 10 acres, maybe it's a rough judge now Indian farmers is doing, but in actual, if you want to understand, if you go with the spacing of maybe 15 or 20 centimeter, and if you have 10 hectares of land, then what amount of seed is required for me? So this data is directly coming to the farmer, right? And how this possible? Because there are different sensors, and that sensor is giving the exact count, right? And say third thing is that we also seen about the, it's not duplicating, right? There is no wastage of seed also, right? There are different metering system over there. That metering system is taking care of one seed at a one time with the right spacing. So this is the technology basically. These are small things, but by using the robotics, by using the right data, by using the keeping the right system parameters, we are reducing the losses for the farmers, and that's how the automation or technology is helping in terms of getting uh, higher return on investment basically, right? So these are few things about the planters we look towards. Those similar things we have related to harvesters also. So let's look, maybe I will continue to share few videos. Then at a glance we can talk on that. Maybe I'll move to that few video topics. So I will reshare again with the audio option.
High performance and efficiency, as well as excellent grain quality, are the winning factors that help the X9 series deliver the low harvesting cost per ton that's so essential in successful harvesting operations. Let us take you on a journey to discover its innermost secrets. The wing movement of plus or minus 10 degrees leads to better ground following and better crop capturing. The projected pivot point technology of the wings enables a tighter reel cutter bar relationship throughout the entire wing range. Wide grain safer belts help to minimize losses in small grain crops like rapeseed to a minimum. The crop is fed head first with support in bushy crops from the fingered auger into the wide feeder house opening. Hydraulic fore-aft tilt control lets the operator adjust the angle of the feeder house on the go for faster harvesting in down crops. The mid-floor pivots to allow more space for high-volume crops. This ensures better crop engagement and a smoother transition through to the rotors. The 8-wing feed accelerator features a chevron pattern. This makes sure that the crop stream is gently pulled apart for an even feeding of the crop into the 2 rotors. Vanes on the front of each rotor ensure a smooth transition of the crop mat into the axial movement and fill the rotors as quickly as possible. Also, due to the counter-rotating rotors, the crop mat is divided without any sharp change in direction. This preserves the straw quality and reduces power and fuel consumption. The proven rotor design with its feeding, threshing and separating zones is carried over from the S series. The crop does 9.5 revolutions in the 3.5 meter rotor, which offers a massive active separation area. The prerequisite for high performance. The crop passes approximately 2.5 times over the threshing concaves, which adds up to a massive threshing surface area. The eccentric shape of the rotor housing with more space at the top creates a pull and release effect as the crop rotates, compressing at the bottom and then releasing at the top. This moves the grain to the outside of the crop flow where it is separated more easily. In high-yielding and high-moisture crops, active concave isolation boosts performance further by maintaining a consistent concave clearance. In the separation area, the crop passes the separation area 7 times, offering a massive separation capacity to cope with tough and wet small grain conditions. The large fingers spaced in a special pattern on the rotor enhance separation, allowing any trapped grain to escape. There is even an additional separation area under the discharge beater to remove those last few grains. A return pan catches all grain from the rotor and returns them to the front of the cleaning shoe. This ensures all materials pass over the entire cleaning shoe area, reducing grain losses even further. The all-new cleaning shoe offers 7 square meters of cleaning shoe area for a superb grain tank sample and a minimum amount of losses. Grain moves from the preparation pan onto an inclined front chaffer, which helps to spread out the material across the cleaning shoe. It also acts as a pre-cleaner. The crop then passes over a large ventilated step to ensure effective pre-cleaning. 4 high-capacity fans provide a constant airflow over the entire cleaning shoe. On rolling fields, Active Terrain Adjust automatically optimizes the cleaning shoe settings to reduce losses and achieve a clean grain tank sample. An active tailings system with smooth rubber paddles threshes the tailings content separately, boosting performance even further without increasing grain damage. The X9 series is also equipped with the revolutionary Combine Advisor automation technology. Cameras in the clean grain and tailings elevators continually measure the grain and sample quality. Combined with sensor information about losses, engine and rotor load, this system delivers consistent output in all conditions, no matter who is driving. The massive grain tank is designed for non-stop harvesting. And when it comes to unloading, it only takes 100 seconds to empty 13 tons of grain. Trailer filling is easy too, thanks to the active spout, which allows the operator to direct the grain flow during unloading. The large diameter auger also runs at lower speed, further reducing the potential for grain damage. The auger is fitted with a cross-auger shutoff. This system allows the operator to empty the auger without having to unload the grain tank, greatly reducing wear and tear. Active yield sensors mounted in the grain tank calibrate the yield sensor automatically and continuously. This maximizes the accuracy of your yield maps, generating data you can trust for future decision-making on your fields. For easy residue management, the operator can simply switch from chop to drop at the flick of a switch. The 124 knife chopper offers superb chopping quality, and thanks to the remote adjustable counter knives, chopping intensity can be varied on the go to match the conditions. Mechanically driven straw spreader paddles blow the straw equally up to 15 meters wide. The X9 series, performance efficiency, grain quality with industry-leading precision ag technology.
Yeah, so we've seen about the how this again precision technologies is used in the harvester. So let's understand little bit in deep what we talk. Am I audible, right?
Yes, yes, you are audible,
Okay.
sir.
Yes, yes. So maybe last video we talk about how the combined harvester works and what kind of different small technologies are involved into that and how those are helping to the farmers. So let me go to that slide where we have this of technology. Yeah, yes. So this is a kind of harvester, but the purpose of showing this is like to understand how this again data, robotics, automation, technologies are working together to give a value to the customers, right? So first of all, understanding the needs is very important. So first version we talk about the is a cutting area, right? So cutting is very simple operation, but in cutting also there are different technologies. So what kind of knives we should use it? What kind of profile of knives? How should be the cutting frequency, speed of cutting, right? So there are different parameters again. So always I'm trying to say that when this machines has been developed at that time when it was a start, so we taken a lot of data, so we understood the requirements. We have taken trials on different crop, different fields, and based on that we understood that if the crop height is this much, then this should be the cutting speed. If the crop density is this much, then this should be our cutting speed, right? So what kind of knife we should use, what is the hardness level, what is the thickness level, it's more of an like there is a separate innovation is going on just on cutting operation of harvesting of, right? So there is a huge scope. So generally we talk about, yes, there are a lot of technologies are available. If we go in a deep, even the wear analysis of cutting bar is also one of the important topic if you want to nurturalize the agriculture innovation. So there are many challenges. We are still in the India, we are looking for the what is the exact cutting speed you should use, what is the there are certain farms where the crop is completely laid down on the field, and at these conditions we are also struggling to get the highest productivity and less crop loss. So there is a lot of things we need to again do it, and this research is going on. Similar thing into gathering, right? We look toward there are different augers are there, different mechanisms, different rollers are there. Again, the speed of roller, the profile of roller, they are creating the different values. There are feeding operations, right? There is a stone trap, because it's not sure every time when the cutting operation is going on only crop will go inside. There might be the case some kind of stone can also enter into it, right? This stone, how that stone will damage again into the different subsystem of combined, so how that stone can be eliminated before it entering into the machine. So there is a stone trap, so that's the kind of one of the innovation. So there are a lot of things basically, and to do the innovation into that, this technology is helping us. We talk in threshing, right? So in India mostly threshing is done by the again there are certain maybe cylinder technologies or walker technologies available in India, but there is a huge scope to go with the rotor kind of technologies, right? We have twin cylinder technology, we have twin rotor technologies. Mostly Europe and US, they are using this kind of twin cylinder technologies. So we can have startup into that area. Maybe the how the threshing can be done with the help of cylinder technology. So this is one of the new research area where we can look into that details, and how we can increase the efficiency of threshing to have the good grain quality. Separating, again, separating is one of the important function of combine, and how the this automation or technology is helping in separating, right? We have different mechanisms we'll be using, different sheaving systems are there, right? Again, grain handling, cleaning, so there are different sheaves, different sharpers are there, right? So this maybe the rate of placement of shoppers, or maybe the vibration that can be provided to the shoppers, or maybe the I would say vibration on the sieves. So these are some parameters, those are creating a lot of values, and that is again data driven. So when the operator into the cabin, when the machine is running, at that time he is himself able to understand whether the whatever the yield he is getting, that is what are the cleaning thing, what is the moisture level of that particular grain, and how much clean percent it is there. It is like 70% yield or 90% clean, or there are a lot of losses into that. He can able to picturize that, and that's because of the different cameras, computer vision technologies are we install into the elevators, right? And that's the reason we are getting that inputs. So it's all integrated, and that is called the precision technology of precision farming. So single simple thing, but with the help of technology, how we are monitoring that things and how we are reducing the losses. That's a good example. Residue management, again, it's the last operation of harvesting, but you know, right, the Delhi area, there's a lot of pollution because of the wrong practices in the residue management, right? We are doing a lot of wrong practices. Farmers are directly burning the residues, right? So this, because of that burning, the pollution levels are going very high. But if you understood the how, what best we can do with the help of residue, if you do the proper handling of this residue, then the quality of soil will get increased, and that's why the spreader is coming into the picture. So we see in that spreader technology, right? The spreader is basically which is cutting down that complete chop or waste of the uh, crop, or maybe the crop waste, into small pieces, and that is just spreaded into over the area, and that is converted into the actually good use for the nutrition for the soil, and that's how the spreading is helping us. And again, there is a different technologies. Some farmer is going for the higher length of chop, some farmer is going for the lower length of chop. It depends on the requirement, field, and again necessity based on the crop field. But the point of talking here or sharing the things are is there are different operations, but in the operation technologies are involved, and that's how the companies like John Deere or maybe CNH or any other competitors, they are doing a lot of efforts how we can helping to the farmers to increase the reduce the loss and increase the yield, right? Maybe we can look few things on the sprayer also, spraying technology. I have one quick video into that. Let me open that also, and maybe by using that we can see some startup coming or maybe problem statement coming out of it, and we can look for that. लावलं का? ओके, येस, चालू झालं. Yes, so on the sprayer side, so this is the self-propelled sprayer basically. So these are the nozzles. So these nozzles again, this is the individual control nozzle. So here we can control exactly. This is a very good example of precision ag. So if you see the nozzle, so what is happening? Just before the entry of nozzle, there is a proportion of water and proportion of chemical and everything is coming up here, and they are actually sensing the area of what crop we have. So they are sensing the exact area. So how many leaves are there? What is the perimeter? And based on that perimeter and number of leaves, they are calculating the flow pressure of the spraying, so that the only pressure will be go or spray will be go into that area. It should not be outside the other areas. So that will reduce the obviously the loss of the fertilizers or maybe the spraying liquid. That is very important. I'm audible, right? Somebody can confirm. Hello.
Yes, sir, you are audible.
Yeah, yeah. Sorry for asking it, but yeah, maybe. What is how much time I have?
Sir, it is already means at 6:30 we have to end the session, and we have to
Okay,
also take some of the question and answer.
okay, okay. Maybe I will
So
just quickly wrap up in one.
you can go ahead, sir. You can go ahead. Yes. Already we
Okay.
have started almost 10 minutes late.
Yes, yes, yes. So I will just request that extra 10 minutes, maybe.
Yes, sir.
uh,
Yes, sir. Please, please.
yeah. So maybe I'll just give one example on that, and maybe we'll look for the question answers. But so in the precision ag, what the important what is what the thing is there is small cameras are there. This camera is actually calculating the area on which the spraying has to be happen, and that is the one thing. And the second thing, it also absorb the moisture content of the leaves and maybe the color of leaves, and based on that they will also calculate the what kind of chemical has to be decided, so that right chemical, right fertilizers and amount of fertilizer is also decided. So this is how data is playing the important role, right? So because of that, there are 3 4 advantage. One advantage is only crop will get spread. That's one thing. We are avoiding the wastage which is going the outside. If there is weed, now green can be on the weed, right? If you say the camera is only taking the green part, then there might be weeds also. So there is a technology which can identify the difference between weed and the crop. So because of that technology, the weed is get separated, only crop area is get calculated. This is the one thing, and that's how the brown and green and green and green. So these technologies are coming up in the seed spray. The green and green means if there is a weed into the crop, then that weed is get identified. That's the green on green, and brown on green means there is a brown land, and green is the area of crop. That's how it is get identified, and based on that, the exact proportion of spraying is identified, and we are using it. That's the losses can be reduced with that thing. Then we have, so there is 3 different premium upgrade, and there are different DC different variant. So again, one important thing, if you see, this is a boom. So this boom has a different segment. So this is the first segment, this is second segment. So there is a technology basically where you can only activate one segment and we can stop the other segment. So this technology is there. So if you want to spray only one area of land and other has to you have to control the less proportion, then that can be controlled with some hydraulic mechanism. That's how it is there. Then third is there. The third is there again. You can have the one section is going on, other section is running. So that's the third technology. So we have different technologies. Basically, and these technologies are really helping again to reduce the waste, right? Because there is an option available with us based on the crop planning and based on the spacing, we can avoid that spacing area not to be sprayed. This is available. This is because of possible because we have different controls and automation. Those are in taking place. So that's how the robotics and automation is creating the value into that. Uh, yeah, I think that was the important thing I want to share. Maybe just 1 minute, I'll just cover up the Tiffin thing. So, as the initiative, the John Deere has started along with the other industry this initiative, basically SAE Tiffin, wherein we are asking students to create a startup kind of thing or kind of small prototype where we can automate the vegetable transplanters. So, there are different 4 stages into that. So stages are pickup system, conveying system, digging system, dropping system, and converting system. How these 4-5 operation can be atomized or automated? How this 4-5 system can be automated? How this 4-5 system can be automated with the help of technology? That's the problem statement we have given to the students, and students are working hard by using some robotics and new technologies. They are managing this automation and they are demonstrating this complete prototype into the actual field. So in March we have this final event, and I invite you all. We have as a convener from this initiative, I invite you all to understand what the innovation students are doing, and maybe you can support to that students with your knowledge to develop that prototype into the commercialization. So it's kind of low cost solution we are providing to the farmers. So this vegetable transplanter can be used for the tomato, chilies, and brinjal crops. So you can find few of the videos in YouTube also about the SAT fund and this theme. You can learn from that and understand the different automation, how the academics are helping to grow the agriculture innovations. So I think that's all from my side. I really want to thank CSMS and AICTE. Maybe we can take few questions if you have.
Yeah, thank you, sir. Now we'll go ahead with some of the questions from the participants. Dear participants, will you please ask some of the questions? Okay, now you can unmute yourself. Now you are allowed to unmute yourself. Hello. Yes, yes, go ahead. Or you can put your questions in the chat box.
Sir, I want to know what is the percentage of implementation, like if you take one state like Maharashtra, to what percentage of the area you have implement all these technologies?
Yes, sir. I think this is a very good question. If you understand the percentage wise, so Maharashtra is a little bit lagging considering the less land holding, but the Punjab and these states, there are more often more on the higher percentage in terms of the crop harvesting side, even in planting also. So I would say around 40 to 45% we are good at the Punjab area, but Maharashtra we are still at the 30%. We are good on the land preparation area where we have the different autonomous tractors and different tillage equipments also there. Now few balers are also coming up. So there we have certain kind of automation, but it's a nice scope if you go with the even the considering the challenges of less land holding and consider that need and providing the right infrastructure even awareness about the student or farmers, we have a good opportunity to increase this percentage levels. But I would say around we are still at the 25 to 30% at the Maharashtra stage. So we have opportunity to go in all the four sectors basically, in land preparation, even in residue management, also even in planting and even crop harvesting.
So one more thing, I don't know whether it is relevant to you or no, I don't know. Even for with the drone spraying and thing, you know,
Yes, sir.
for spraying from the drone. So, what do you think that what is the percentage still now it has been covered in India or with respect to any of the state?
Yes, sir. I
How
think yeah. Okay. So in terms of the drone technology, so right now we have a prominent application on the spraying, and even there are few startups coming up from the Mumbai region. They have very good volumes, and they're also increasing the scope from the rather from spraying also the understanding the nature of or health of crop also, like we seen on the weed control, like we seen on the understanding the moisture controls also with the help of infrared technologies, but by using the drones only, right? They are integrating some computer vision and understanding like is there a difference we can create from the different kind understanding different kind of land pattern also, right? There are different slope compensations available, right? So how the slope compensations are affecting on the productivity. So this kind of inputs or this kind of studies happening in the drone technology. So now we are limited up to the just for spraying and mostly on the spraying, but this the scope can be again maybe increase or enhance for the other applications also, like we say understanding the land pattern or weeding controls and understanding the monitoring the health nature of the crop. So these are few areas where we have the huge opportunities incubation of the spraying technologies or using the drone into that. But yes, the good thing is that there are many startup coming up, many companies are promoting this, and even at the academia also there are many institutes they are working very hard to take the different trials. So it's growing, I would say. There is a good future and scope also, I would say.
Yes, sir. Thank you. One more last question.
Yes, sure, sir, sure.
With I hope the workshop coordinator will permit me to ask this question. Sir, what I feel is now in India, our land holding are very, very small.
Yes,
I feel that John Deere should look into developing some of the equipments which are very, very small like equipments. See, there are farmers who has got a capacity of who has got land holding of somewhere about 1 acre land, 2 acre land. See, if you ask them to do harvesting or spraying with the drone or things, it's a costly affair for them there. So I feel
correct.
like harvesting is there. 1 acre land, I want to harvest. I want to harvest some chili, some chili in half-acre land. So I should have a small equipments which can be done by manually by taking that and doing it. Small equipments.
Right.
So that no they can do it manually. It should be semi-automated, not totally manually there. It should be semi-automated there. So in that case, no, it helps to the farming community too much.
Right, sir, right.
If you see there, if you see the overall scenario in India, no, what is happening is many of the people who are farmers now farming has become it has become a part-time job. Not all the farmers are full-time job. Some farmers they work in the nearby cities. Saturdays, Sundays, holidays, they work in the field. Who are having 1 acre land, 2 acre land. So for them also, no, we should provide something like no this kind of this kind of small equipment, and or if you are telling something about the weather pattern or soil moisture pattern. It should come on some very good applications on the mobile applications should come then. Sir, I have seen there, no, many people speak about the very hi-fi technology like sensors and drone, like satellite images and thing there. It is, if I see there, my experience tell that it is hardly not even 10% it is working on the field.
Right.
Like if you tell about the sensor, soil moisture sensors, let us take the example. What is the percentage of people? What is the percentage of farmers who are working, taking help of soil moisture sensors? I don't think so. Many of the farmers not even taking the soil moisture sensors. So
Right.
I feel that this technology should come a little bit cheaper way, and it should be applicable to the field then.
Right, sir. I think you mentioned the right pain points and even challenges. So that's because of less of motivation, sir. You're right. So farmers are not much adaptable to new technologies and all because the cost is involved and even infrastructure is not that much of enhanced so that they can use these technologies. I think you mentioned the example of sensors and all the using it. But yes, that's a real scenario. Now, that's the reason basically the companies like this off highway forum, they are coming together and they are creating an ecosystem. So basically. These initiatives we are bringing up like a Tifan or maybe we are collaborating with different agriculture universities and we are promoting some few of the startups to develop this kind of small machines where maybe the less land holding is the challenge, but that's not a limitation, right? That's not a stopping us to develop something new, right? So we can develop a machine with the smaller track width, right? We can change the wheelbase. As you said, that cannot be a complete automation. There can be semi-automatic machine, right? Now the one topic I missed, the EV. Basically that was the one of the important thing. We can use this, we can take some of the e machines, and with the help of e machines we can develop this kind of smaller machine instead of going for the four-wheel drive, or maybe we can go with the two-wheel drive with the smaller turning radius machine, right? So
Yes,
there is,
yes.
yeah, so this kind of few things, if you use that, then these challenges can be mitigated. I think the off highway board is doing a lot of efforts about developing these machines, but still there is a lot of scope and a lot of support is needed. So that's the reason, sir, this initiatives like Tifan, we are helping them, the students and academia or maybe few startups to coming up with this problem statement, and we are helping from technology point of view how this technology can be implemented for the India and we can increase our level of adaptation basically. Yes, but there is a way. It takes a long time, but yes, there are opportunities and we should look into deep. You mentioned right there.
Okay, sir. Thank you very much. I also thank the workshop coordinator, Wankade sir.
Yeah, thank you, sir. Thank you very much.
Yeah, sorry for my speed because there are a lot of things cover, and maybe other maybe few things I'm not able to cover well, like the how the off highway can be go with the EV technologies and all. There are a lot of opportunities, but nevertheless, I think I can understand there are very few things which may not be possible for India, but at least we should try to use at least 10% of them. Maybe considering our situation, considering our duty cycle, environment condition, that will surely help our farmers to go in deep. That's there. But I really want to thank you and maybe the AICT and CSMS to bringing this kind of development programs and creating the awareness. At least we are also learning many things from the others, and collaboratively we can develop for our nation, our country. Yeah, thank you for that.
Rajput sir, I just want to join with us for a group photo with all the
Okay.
participants.
Sure, sir, sure.
Yeah, I request all the participants, they can start their videos so that we can have a group photo here.
Sure, sir. I may not be at a perfect attire, but yeah, maybe for this.
Sir, will you please stop sharing your screen?
Yes, sir, yes.
Yeah. Okay. Okay, so we'll take some of the photographs. Yeah, I'm taking the photographs of this slide. Just a minute. I request all the participants, they can switch on their cameras, so I can take the photograph of each one of you. Let me take a few more photographs so that those who are recently joined for the group photo, I will take the photo. Now we'll move ahead with the, you remain there in the meeting, keep your videos on. Now, because we are moving ahead with the some feedbacks from the participants.
आवाज करा तू जाणार नाही आवाज जास्त नाही लाव.
So the principal of the CSMSS, Chhatrapati Shahu College of Engineering, also joined with us. Good. I request some of the participants be ready with the feedback so that whatever our future FDPs will be there, so we can improve them. I'll put all these photographs in the chat box so that also in WhatsApp group also.
Sandeep Rajput sir.
Hello, sir. Good evening.
Good evening. Thank you very much, sir. As always, you are supporting our student and you are mentor for our Tiffin team. So always your technical aspects and technical insights are useful for the student. And today in FDP to all faculty members also, you have given very good insight. So from CSMSS family, I thank you, sir, for your contribution.
Yes, sir. Thank you very much for me to again provided by many small knowledge to all the participants. I think it's a good opportunity, and I know always CSM is always supporting to deliver this kind of programs and be creating the new value to the academics and industry. That's a good effort in terms of the collaboration. So again, it's my pleasure on the day. Thank you for the opportunity, sir. Thank you very much.
Thank you, sir.
Thank you, sir.
Okay, so I have taken the photographs from the Zoom meeting. I request some of the participants, they can unmute themselves and they can share their thoughts and some of the feedback related to the this 6 days online faculty development program, which was organized by the CSMS Chhatrapati Shahu College of Engineering. Yeah, there are few participants, they have raised their hand. Mr. Amit Dolos is there. Sir, would you like to share your feedback?
Yes, first of all, good evening.
Sir, you are not audible.
Sanam Salman Kazi ma'am.
Good evening, everyone. Myself, Professor Sanam Salman Kazi from Bharati Vidyapit deemed to be University, Navi Mumbai. And I am very happy that the topic of the FDP was very nice because many scholars research scholars are working in this research area and we read many papers. So, when the content of your FDP is really useful for all the research scholars when they map their learning to the research papers and the case studies which were discussed by every speakers, it was based on their personal work, which really helped us to understand that what other scholars are doing in their work. So I am very happy that this was not just theoretical, it was sharing of the different research work which they are doing, hearing out the concept, industry experts, they have taken it to their level. So overall, it was very, very nice. And I'm very happy that I joined this FDP. There was lots of option from ATAL. And I'm very happy that I selected this. Thanks to the college management and the organizing team. Everything is very good and very excellent. Thank you.
Thank you, ma'am. Thank you very much. Yeah, Professor Jain Jagpal, sir. Jagpal, sir. Please unmute yourself.
Hello.
Yes, sir.
Good evening, sir.
Good evening.
Good evening to everyone. I am Dr. Jain from NIMS University, Jaipur, Rajasthan. I am thankful for Dr. Wankhede and team for organizing such a wonderful workshop. And I am thankful for CSMSS and ATAL for providing support for organizing informative workshop. This workshop, I can say, was really a bridge for covering many topics. You can say from beginner to the expert, from national to the global, from academia to the industry. So many aspects of the research and the actual implementation part were covered. Those who were having potential, they can fly from this level. Those who are beginner, they can start jumping into the great things. And I can say such kind of workshop should happen again and again. And I request Dr. Wankhede and team to have such kind of wonderful workshop in future also. And possibly I request for some hybrid workshop so that we can have more interaction face to face.
Yes, sure, sure.
Thank you very much.
Thank you. Thank you, sir. Thank you very much. Dr. Aarti Wadekar, ma'am. Ma'am, you are not audible. Okay, we'll take another participant, Mr. Subhash Kamdi.
Yes, good evening, sir.
Good evening.
Good evening, sir. First of all, congratulate all the team of CSMSS, Chhatrapati Shahu Engineering College, and also I congratulate Dr. Wankhede sir. He organized good speakers and valuable information shared by all speakers. Nicely, I have no words to express all this, how to express all the sessions. Very nice speakers organized, and few speakers give the very much share the video very nicely. These topics are basically useful to everyone, definitely, but most useful. And I have got very much large information to us because I basically a farmer.
Yeah.
So that's why I have taken very much, and I will be use all this technology. I will try to use this technology to improve the farmer suicide in my district, that's Yautmal districts and Varda districts, that belong to heavy sufferer due to the pesticides problem and animal damage, crop damage. And also I have done on this works, but I have tried to find out all the techniques on traditional ways. But you have given the AI techniques and also deep learning methods, also given the knowledge. So nice sessions, all the nice sessions. And once again, I congratulate Dr. Wankhede and all the teams. Thank you, sir. Thank you.
Yes, sir. Our complete team have actually identified all the speakers. So it's that teamwork is there. So thank you for joining the workshop, sir.
Thank you, sir. Thank you.
Yes, ma'am. Dr. Aarti ma'am, would you like to say something?
Yes, am I audible, sir?
Yes, you are audible.
Okay, good evening to all of you. So, myself, Dr. Aarti Vadekar from Devgiri Institute of Engineering and Management Studies, Chhatrapati Sambhajinagar. So, during this last 6 days, received here the insights of the various technologies and their applications in the agriculture, from the data-driven decision making to the automated systems. Especially, I would like to say here, Dr. Vinaya ma'am, that is AI for Agriculture Data Analysis, and Dr. KB Khanchandani sir, that is crop disease prediction, that help us to identify here the research area in this domain. So I would like to express my heartfelt gratitude to the organizing team for such impactful sessions, and the speakers for their time and your the expertise. So thank you all for making this FDP a remarkable experience. Thank you, CSMS College.
Thank you, ma'am. Thank you.
Good evening, sir.
Good evening, ma'am.
This is Janani. I'm a research scholar from Shastra University. Actually, we are in the initial stage of our research, and the FDP session was very useful. Like we learned, I learned many things from that, and we are doing the research especially for Kaveri Delta region. It is in south side, like Tiruchi, Tanjavur, Nagapattinam. In those areas, they are requiring such kind of smart agriculture a lot. So I was able to learn a lot from this FDB, sir. And I'm also keeping a request, like if you are like can share the PPT even after the test, it will be helpful for us, sir.
Yes, sure.
Yeah. Thank you, sir. Thank you.
Professor Rajendra Shinde, sir.
Thank you, sir. First of all, I would like to congratulate the entire team of the CSMSS for organizing such a wonderful program. Such kind of FDPs really helped out to all the participants, as the various content on the sustainable agriculture practices, their challenges and opportunities were covered into this. And the best part that I like was the AI for the data analysis and the predictions, as well as the forecasting, the mobile based seed quality detection. So many of the advanced areas had been covered under this FDP. So the resource persons were also the at par with the knowledge as well as the content. So this was altogether the complete package that we were looking for in the area of the sustainable development as far as the agriculture practices are concerned. So I'm very much thankful to Wankhede sir, as well as the our Vice Principal DL Buyar sir, and many thanks to our Principal sir, Dr. Ganesh Dongre sir, who always encourages us to organize such kind of programs. So thank you all.
Thank you, sir. Thank you. Professor Amit Bajare, sir.
Good evening, sir. Hello.
Yes, sir. Yes.
Yes, sir. Good evening, sir. Sir, myself is Amit Bazare. I am from Shegaon, and presently I am working at Siddhivinayak Technical Campus, Shegaon. The session was very extraordinary and very helpful. One of my friend, my colleague is uh, Professor Avinash Bhopde, and me working on IoT devices in farmer or farmers. We both from farmer families, and the session was very nice. Very first session is very informative, and Professor Gokar madam having very good session, and Khanchandani sir also having very informative session for our research work. Thank you, sir, for your team and Professor Wankhede sir. Thank you, sir.
Thank you. Professor Rupali Sharma, ma'am. Ma'am, please unmute yourself. Rupali, ma'am. No, yeah.
Am I audible?
Yes, you are audible.
Good evening, one and all present over here. First of all, I would like to congratulate the complete team. Whatever efforts you have put up for conducting this FDP, it is really very informative as well as helpful. Uh, I feel that first of all, when I have registered for this FDP, I just want to specify my words genuinely. I was thinking that it's an online FDP after completing the whole day schedule. How come we are going to attend the 3 hour session, right? But every day it was so informative and knowledgeful that we were excited that what new things we are going to study today, because many times it happens that by completing your complete schedule, referring so many papers, you have to do your research work, right? And here you have given the whole thing together. We got the complete package over here, that after reading so many papers, whatever information you're going to get, you're getting all these things just within a 3 hour session or 6 days session. So it was really helpful. I would like to request only the one thing, whatever PPTs they have shown, right? The speakers have given. Please, if you will share it, it will be really helpful for us. Okay.
Yeah,
Thank you very much, sir.
Thank you. Thank you. Professor Thodas is there.
Yes. Good evening, all of you. Myself, Amit Doras from SSGMC. First of all, I congratulate Principal Sir CSMSS, Vice Principal and Head of the Department, Dr. Buyar Sir, and Wankhede Sir, Dr. Wankhede Sir, and the complete team for organizing such a nice workshop for we people. As we know, the farmer and agriculture is the backbone of the country. So it is very much important to improve the technology or some improved trends in the technology in the field of agriculture is very, very important. So in that sense, the nice sessions as well as nice theme is opted for the FDP. That is very much appreciable. And again, I thank all the team as well as participants, and thank you very much.
Thank you, sir. Is there anyone who would like to give the feedback? They can unmute themselves and they can share their feedback. Okay, so
Good evening, sir.
yeah, ma'am.
This is Shalini, research scholar from Amrita University, Bangalore. So I would like to thank all the coordinators for their support in conducting this FDP. All the entire sessions which was done for all the 6 days were really helpful for research scholars. And since I am working in the field of crop yield prediction, Most of the topics discussed were relevant for my research work. And there were even hands-on coding sessions, which were very helpful for most of us. So thank you. Keep conducting such FTPs, which will be helpful for all academia. Thank you.
Thank you. Thank you. We have a request from some of the participants regarding the test link. I'm going to share the test link in just in 2 minutes. Something, sir? No. Then Dr. Zavre sir is there. Sir, would you like to say something? Because you have raised your hand.
Good evening to one and all. Myself, Dr. Tushar Zavre, currently working as a Dean Research and Development at R.C. Patel Institute of Technology, Shirpur, Maharashtra. I would like to congratulate the entire team of CSMSS and Dr. Bhuyar and Dr. Praveen Wankhede sir for the efforts taken for the successful conduction of this workshop. The topic is really nice. We got a very informative from this session. They have provided the different research directions for the researcher. In the sessions, Dr. Kanchandani said that regarding the smart farming. So I request all the technocrats. So we should provide the technology to the farmers in such a way that it should be really sustainable. They should get it with the very low cost, and it will be really useful for the farmer. So again, I would like to congratulate for selecting such a nice topic, so that we can really provide something for the farmer, because we know that the farmers are the backbone. Agriculture is the very much backbone of this our GDP also. So thank you. Over to you.
Thank you, sir. Professor Praveen Shirode, sir. Sir, would you like to say something? Sir, please unmute yourself. Sir, your video is on, but your mic is in off. So please unmute yourself.
Hello, I'm audible?
Yes, sir. Yes.
Okay, thank you. Thank you very much for arranging such a wonderful sessions on the agriculture to the AICTE, your institute, and the whole team. And on the behalf of whole farmer family, I request to all participants, please transfer it on the farm. So thank you very much. Thank you, sir.
Thank you, sir. So now we'll move ahead with the validity session of this faculty development program. So today we have with us the principal of CSMSS Chhatrapati Shahu College of Engineering, Dr. G.P. Dongre sir. Then the convener coordinator of this faculty development program, Dr. D.L. Bhuyar sir, and the principals, deans, head of the departments, and all the participants of different colleges. In last 6 days, we have gone through the different sessions from simple development of or implementation of the IoT at the Ramthal, which is described by the Abhijit Joshi sir. And then we have seen other sessions also from AI to deep learning, then from computer vision. So we have lots of things we have seen. I really thanks all the experts who actually accepted our invitation and delivered the different talks. So as we are moving to end this session, I request Dr. G.P. Dongre sir to give a concluding remark about the FDP. Sir, please.
Thank you so much, sir. Am I audible?
Yes, sir, you are audible.
Sir.
First of all, a very good evening to one and all. Esteemed guests, respected faculty members, and dear participants and colleagues. First of all, I want to congratulate the team for this wonderful FDP. It gives me immense pleasure to share with you today at the valedictory function of this enriching 6-day online ATAL faculty development program on leveraging cutting-edge technologies for sustainable agriculture practices. Over the past week, we have witnessed a dynamic exchange of knowledge and ideas, and I'm truly delighted to be a part of this significant occasion. As we reflect on the program's success, I would like to begin with congratulating each one of you for your enthusiastic participation, commitment, and intellectual engagement throughout the session. This event was meticulously created to equip you with the latest tools, strategies, and technological advancement that are reshaping the future of agriculture and ensuring its sustainability. In today's world, agriculture faces unprecedented and challenges, whether it be climate change, resource depletion, or the increasing demand of growing global population. However, with the integration of cutting-edge technologies, we have the opportunity to transform these challenges into solutions. From precision farming and artificial intelligence to drones, remote sensing, and biotechnology, these tools are revolutionizing the way we approach sustainable agriculture practices. During the past 6 days, we have deeply into how these technologies can enhance productivity, minimize environmental impact, and promote more sustainable, resilient agricultural system. The variety of topics covered in this session, from data-driven agriculture to soil health management, has opened new doors for us to not only understand but also apply these innovative solutions in our professional practice and research. I must take a moment to thank our distinguished speakers and facilitators who have been the key drivers of this event. Your expertise, passion, and dedication have undoubtedly added tremendous value to this program, and I am confident that your insight will continue to inspire all of us. We move forward. To the participants, this program was not just opportunity to learn from experts, but also to build a network of like-minded individuals who share a common interest in advancing sustainable agriculture. I encourage each one of you to stay connected, share your experiences, and collaborate as we all work towards a greener, more sustainable future. I am also proud of the way this online platform has brought together people from different parts of country, overcoming geographical barriers. It is a testament to the power of digital learning, and I am confident that this is just the beginning of many such fruitful collaborations. As we conclude today, let us remember that the knowledge gained here should not remain confined to the virtual space we have shared over these 6 days. It should be carried forward into our classrooms, research, and agricultural practices. Let us make a conscious efforts to apply these insights in our respective areas of expertise, be it in teaching.
Sir, you are unmuted in the picture.
It should be carried forward into our classroom, research, and agricultural practices. Let us make a concise efforts to apply these insights in our respective areas of expertise. Be it in teaching, research, or policy making, to foster sustainable agriculture that benefits both the environment and society. I congratulate to Electronics and Computer Engineering Department of Chhatrapati Shahu Maharaj Shikshan Sanstha's CSMSS Chhatrapati Shahu College of Engineering for organizing such a wonderful FDP. In closing, I extend my heartfelt gratitude to our CSMSS President, Honorable Sri Ranjit Mule sir, Honorable Secretary Sri Padmakar Raoji Mule sir, our Administrative Officer Sri Dr. Srikant Deshmukh sir, Vice Principal Dr. Buyar sir and his team, heads of the department and all the faculty members for their continuous support and encouragement. Everyone who contributed to make this faculty development program a success. To the organizing team, the participants, the speakers, and all the stakeholders who supported this event, I express my deepest gratitude. I am confident that you all will continue to explore, innovate, and contribute significant to the field of sustainable agriculture. Let us work together to build a future where agriculture is not just productive, but also sustainable, resilient, and in harmony with nature. Thank you. I wish you all the very best in future endeavor. Thank you so much. Over to you, sir.
Yeah, thank you very much, sir, for your motivation and your time to time support for organizing the different events. So many people are actually taking my name as a coordinator for the faculty development program, but as I am talking with all the participants and experts during these last 6 days, but before starting with this faculty development, means before coming the concept of this, the idea of this faculty development program, the idea was from our coordinator, that is Dr. D.L. Boyer sir, to go ahead with such type of topic. Our team, along with our coordinator, we have finalized very different speakers. Then we have finalized different topics and the speakers and everything. So actually, though I am in front of you, all of you, but at the back end, the time-to-time support, one person is working, that is our coordinator, Dr. D.L. Boyer sir. So I request Boyer sir, please give your final remarks and vote of thanks. Sir, please.
Thank you, sir. I am audible, sir.
Yes, sir. Yes.
Good evening, all. It is both honor and privilege to sit in front of you and propose the vote of thanks. This responsibility is given to me. I extend my heartfelt thanks and gratitude on behalf of CSMSS family, Chhatrapati Shahu College of Engineering, for the successful conclusion of this enlightening and impactful 6-day faculty development program. We have witnessed an insight and discussion, expert lead session and knowledge sharing that have empowered us with valuable perspective on the integration modern technology advancement into agriculture. These innovations are crucial in transforming agriculture into the modern, sustainable, efficient, and environmentally conscious sector. And we are grateful to have explored with the help of this 6-day program with all of you. I would like to first extend my sincere thanks to our esteemed resource person and expert, those who have spared their valuable time in busy schedule, who share their vast knowledge and experiences. Their contribution have made this program an incredible success, and commitment to promoting sustainable agriculture through technology is truly commendable. A special mention to all our faculty members, and without participants, there won't be any program will be successful. So the participants, those who are continuously in evening, one of the Madam Sharma Madam has given the feedback. So even evening they have 6 to 9 by AICTE. So at that time also, all participants had enjoyed the sharing. That is the receipt of the program, and that team we have selected under the guidance of our principal sir, the speakers, and for that we are thankful to everyone, the participant. Their contribution made this program very useful, along with a special mention to all faculty members, those who are continuously, everyone who are busy in programs, so they have participated. Your enthusiasm and active participation and engagement have the very important success of this 6-day program. Your curiosity for asking the questions and the engagement to interactive learning is very important for us to drive such program to have meaningful outcomes. I would like also thanks to the organizing committee, efforts taken by the team members every time to run this program smoothly. The technical support, IT sections, and the electrical sections, everyone were present for this program, and they have made their part successful. Last but not least, I express my gratitude to our President, Honorable Sri Ranjit Mule sir, Secretary, Honorable Sri Padmakar Raju Mule sir, Administrative Officer, Honorable Sri Srikant Deshmukh sir, our beloved Principal, Sri Ganesh Dongre sir, all head of the department, my colleague, faculty members, and class 3 and class 4 also, for their continuous support and encouragement. Their vision for integrating technology into our academic and research practices is what allowed this program to take place. As we conclude, I encourage all of us to apply the knowledge gained during this session to our own teaching practices, research, and futures endeavors in the real and sustainable agriculture. As one of the participants, my friend Praveen Shirode sir has mentioned that only not for the learning, we have to move towards the farm and accept the challenges of the farmer and provide the solutions technically which is helpful for the society. Let us continue to work together to find innovative solutions for more sustainable and prosperous futures. Once again, thank you all of you participation. Embrace your work in future too. Thank you and have a great day. Thank you very much.
Thank you, sir. So with the permission from the principal, sir, I would like to say that, sir, I shall conclude the ceremony.
Yes, sir. Please go ahead.
Yes, sir. Thank you, sir. So, dear participants, now we'll end today's voluntary session as well as the faculty development program. We have shared the test link in the chat box itself. Please appear for the test, because it is important that you have to clear the test so that we can upload your marks on the AICTE portal, without which actually you will not get the certificate.
Okay.
So thank you all the participants. After uploading your attendance and the marks on the AICTE portal, it will take 2 to 3 days to generate your certificate on AICTE portal itself. So after possibly you will check your AICTE portal. You'll just log into your AICTE portal, sorry, AICTE ATAL portal, and possibly by Tuesday itself. So there may be possibly you will get the certificate from Tuesday in your portal itself.
Right. So wish you all the best. Good night and take care.
Thank you very much.
Take care. Be in touch. Thank you.
Yes, sir. Thank you.
Thank you.
Right.
Thank you all, dear participants. Thank you.
So now I'm closing this meeting. Those who are yet to get the link, I request them. There is a test link in the chat box itself. I am again sharing the link. Dear participants, now you can leave the meeting. I am ending this today's meeting. Thank you all of you for joining this faculty development program.